All right, so Javon, I want you to read question 29 real quick. Real quick.
The n term of a sequence is defined by Tn equal to 4n squared minus 7. Write down the first four terms, and hence determine whether the sequence is arithmetic, geometric, or neither.
Okay, so if I want to figure out the first four terms, what do I have to do?
It would be T4 equal to 4n squared minus 7.
Wait, they're asking for the first four terms. So if I ask you for the first four terms, so if I ask you to count the number four, how much numbers you count?
4.
Right. So your first term will be T1, right? In T1, what is N? What is N in T1?
4n squared minus 7.
Right. But if we want to find T1, right? Compare it. Compare this to this. What is N? If you're comparing this to this, what is N? N represents
One.
the term. So if this is the first term, what are we going to substitute for N?
1.
Right. So anywhere I see N, I'm going to put 1. So that's going to be 4, 1 squared minus 7. 4 by 1 is?
4.
4 minus 7 is minus 3. That's the first term. The second term is going to be 4 by 2 squared minus 7. So that's going to be 4. 16. 16 minus 7 is 9. Just verify that. The third term is going to be 4 by 3 squared minus 7. That's going to be 36 minus 7, which is 29. So you'll just verify I'm doing the maths correct.
Yeah. Yeah, 39.
All right. And then the last term, what am I replacing N with?
4.
4. So that's going to be 4 by 4 squared minus 7. So 4 squared is 16. 16 by 4 is 64. So that should be 57. Just verify that.
Yeah, correct.
Okay. So we need to figure out if it's a AP or a GP. All right. So are you noticing any patterns? So first things first, how do you know if a series is an AP or a GP? How,
Um,
how do you tell if a series is a arithmetic progression?
I really don't know. It's just like look like a AP, or it's like look like a GB. I don't know how to explain it.
Okay, so if a series is an arithmetic progression, that means to get the next term, you have to add the same number. So an example of an arithmetic series, so we're just gonna do a crash course on it, right? So an AP, an example would be like 5, 10, 15, 20, 25. I want you to check that out. To get the next term, what did you have to do with the previous term?
Add 5.
Right. So our arithmetic progression has a common difference. So it has a common difference, D. So what that means is let me just say to find D, the formula is Tn minus Tn minus 1. So Javon, all that means is you're taking the second term and minus it from the third term, so on and so forth. So if I wanted to find the common difference, I could say 10 minus 5. Where's 10 minus 5?
5.
Okay. Give me an example of two other terms I could use.
20 minus 15.
Or I could use 15 minus 10. Yeah. Um and then I could use 20 minus 15, like you said, and that'll be equal to what?
5.
So are all the terms linked together by a common difference?
Yeah.
Yeah. So that's how you prove that something is an AP. Now, if something is a GP, let me show you how that'll be related. This is an example of a GP. And GPs have common ratios, right? And the common ratio is found by taking the next term and dividing it by the previous term. So an example of a GP is 2, 4, 8, 16, 32. So Javon, if we want to check if it's a GP, what you have to do is you have to take the second term divided by the first term, so on and so forth. So to find common ratio, I could say 4 divided by 2. And Javon, just by looking at this, What do you think you have to do with each term to get the next term?
Multiply by 2.
Right, so we're supposed to get 2 for the ratio. Let me try another one. Let me just try, give me two other numbers to try. Any other numbers?
Um, 16 divided by 8.
Right. So if it's correct, it should be consistent for at least 2 terms. And yeah, would agree if I say 32 divided by 16, I'll get 2 as well.
Yeah.
So that's how you prove if something is a GP or AP. Now, Javon, in this case, we got these terms. And Amy, I just wait to be on standby to see if I'm doing the small maths correct, right? Because I'm not really bothered with the small maths. I'm also concerned with the format and the concepts, right? So, Amy, you'll just make sure I'm doing the maths correct, right?
Yeah, everything you have right now, correct.
All right. So, Javon, if I were to list the 4 terms, it would be T1 is equal to -3, T2 is equal to 9, T3 is equal to 29, and T4 is equal to 57. So if I were to write this out, if I were to write this as a list, I would say -3, 9, 29, 57. So Javon, just by looking at this, can we figure out if it's an AP or a GP?
Yeah.
Yeah? So tell me,
Yeah.
you think we have to wait and
Um,
add to get the next term then? Or would I have to add to get 9 from -3? -3 plus what is 9? So if you want to check if it's an AP, so you're saying it's an AP, right?
yeah.
So if it's an AP, it should have
You'd
a
rather add 12
so if it's an AP, it should have a common what? It should have a
difference.
common difference. So let me try to find the common difference here, right? So it will be 9 minus -3, and you'll get 12, right? Okay.
Yeah.
Let me try it with 2 other terms. Give me 2 other terms to try it with.
29 minus 27.
No, you have to be very careful. It's all
Not 27. 29 minus 9.
wait. Or 29 minus 9? That's what you
Yeah.
say? Okay.
Yeah.
What is 29 minus 9?
20. 20.
20, right? So if you look at that, do they have a common difference?
No.
No, so this is not an AP. Okay, let's move on quickly. For the to check if it's a GP, it needs to have a common ratio. So give me 2 numbers to divide by. It must be consecutive terms.
9 divided by minus
What is 9 divided by -3?
-3.
Okay, give me 2 other terms.
29 divided by 9.
29 divided by 9. All right. If you divide 29 by 9, what are you gonna get?
3.2 recurrent.
Or are those two different?
No. I mean, yeah, they are different, so it's
All right,
neither.
it's 9. Right, so the correct answer is neither. Right, let's keep moving on. So write the sum 5 plus 10 plus 15 plus 100 in sigma notation. Right. So Amy, do you remember sigma notation?
Yeah, I think so, a good bit.
All right. So in the sigma notation, you have the sigma summation sign. You have in the bottom, you're going to have some value I, and that's going to be from where you're starting from. The value over here is going to be the value where you end at, and you're going to have the general formula over here. So
Mhm.
let's try to figure out all of that for this particular question. So Javon, if we look at this, what does this look like? This look like an AP or a GP?
AP.
An AP, right? And let me just find the common difference first. The common difference, we can say 10 minus 5, that's 5. I could also say 15 minus 10, that's 5. So we know it's a GP. We confirm that, right? Now I need to figure out the general term. So I want you to check through the formulas. Well, how would I represent general term for an arithmetic sequence?
A plus n minus 1d.
Right. So T of n is going to be equal to A plus n minus 1 by D. So like I said, in the summation form, this is the value you're starting off to plug in to generate your first term. This is what you're going up to, and this is your general expression. So Javon, what is my first term? A, by the way, A is the first term, right? A is the first term. A is the first term,
5.
right? 5. I'm generating the general term, so I'm going to leave n blank. So n minus 1. And what is D?
5.
So we need to expand this and simplify. So that's going to be 5 plus, if I expand this, tell me fast, what am I going to get?
5n minus 5.
Right. Right. So the 5s would cancel off, so that would leave you with 5n. All right. So Giovanni, good, right?
Yeah.
All right. So that being said, we need to figure out where we are starting at and where we are ending at. So Amy, if I want to figure out my starting value for n, what I could do is I could say 5. So 5 is my starting value. I could say 5n is equal to 5. And Amy, if I say 5n is equal to 5, what would n be equal to?
1.
Right. So Javon, we're starting at 1. And so Javon, if we want to figure out where I'm ending at, if I want to know where I'm ending at, how would I do that? How would I figure out where I'm ending at? So to figure out my starting value for n, I use the general formula and I use the starting value. And I said 5n is equal to 5. So n would have to be equal to 1. And Javon, you could see it. And 5 by 1 is 5?
Yeah.
Right. So now we need to figure out what term we're going up to. So in other words, this sequence is stopping at 100.
Yeah. So 5n equal to 100.
5n is equal to 100. And so what would be the last value I plugged in for n to generate that term? N would have to be equal to what?
20.
Right. So if I'm writing this in sigma form, it would be, so the general expression would be over here. So Javon, what's the general expression we came up with?
Um, 5n
Right. And I'm plugging in what initially? What am I plugging in initially?
first term by I. So
So I is basically whatever the variable over here is. So we're using n, right? So you're gonna say n is equal to what? And what is the first value for n we're plugging in to get the first term? So what we have,
1.
right. So to get the first term, you're plugging in 1, and to get the last term, which is where you're going up to, you're gonna plug in what into 5n.
Wait, repeat that?
So this
Yeah.
is in the summation form, this is what you're gonna plug in to get your first term. And this, where I put on top, that'll be the last thing you're plugging in. So what is the last thing I'm plugging in? Into 5n,
20.
20. Right, so that's it. That's it. This is the answer. And so Giovanni, understand that if I were to expand that out, I would say 5 by 1, then plus 5 by 2, then plus 5 by 3, all the way to 5 by 20.
Yeah.
And 5 by 1 is 5, 5 by 2 is 10, plus 15 all the way to 100, which is what we see in here, which is what they wanted us to generate. So we good. So that's how you write something in sigma notation. So let's keep moving on. Right? Amy, you go with that?
Yeah.
Okay.
I just had mine's equal to what they had on top, like the equals 5 plus 10 plus 15.
You don't have to do that, but that's optional. That's optional. They said
Okay.
they said they wanted it to write it in sigma notation. So this is in sigma notation. That is in sigma notation.
Okay.
But optionally, if you want, you could put it equal to 5 plus 10 plus 15 plus dot 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 plus 100. That's correct. But this is all you needed to write. That's equivalent to this in sigma notation. Annalie, I noticed you joined a bit late. Is everything okay?
Yeah, I now reach home, so
Oh, okay, okay. Oh, because I think you had something, you had chemistry or something.
no, I just went to address.
Okay, okay. So, Annalie, we're doing a kind of speeding through series and sequences, and after that, we're going to move on to calculus, right? What I just now showed is how to go from the general, from like when they list it out as a sequence, we're going from that form to sigma notation. I just now discussed that. If that's something you don't understand, let me know.
No, I get it.
Okay. Kiara, are you there?
Yeah.
Okay, so Kiara, just go over this thing fast. This over
I
here.
was here for it.
Oh, you good, right?
Yeah, I was here for it.
Okay. So no matter what you get, you're going to figure out the general term. So you listen to the process. You need to figure out if it's a AP or if it's a GP. To figure out if something is an AP, you check to see if it have a common difference. And Javon, can you just check one consecutive term? If you want to check if something is an AP or a GP, can you just check it for one pair of consecutive terms?
E no.
No, you need to do at least two, right? And make sure it's the same value you get in. Right. So if D is the same for like two consecutive values, you know it's an AP and you know what D is. The next thing you do, regardless, if it's an AP or a GP, you need to remember the formulas. So in this case, we're dealing with an AP, so you need to figure out the general term. The general term for AP is A plus N minus 1D. So we figured out the general term, and we figured out the first term would be 5, and so N would be equal to 1, because 5 by 1 is 5. And we figured out that the last value for N would be 20, because 5 by 20 is 100. If it was a GP, you would repeat the same process. The only difference would be how would have a common ratio. You would have to use a different formula. Kira, remind me, what is the general formula for a GP? Tell me fast. What is the general formula for a GP? Kira, in the original formula sheet I sent, the one with 18 pages, go to page, if you want to see all the formulas, go to page
I think it's like page.
9. Check 9.
Yeah.
What's the general formula for GP? Tell me fast. All right, so the answer is AR to the power N minus 1. That's the general term.
Oh wait, I was on the wrong formula sheet.
Right, so the general term is AR to the N minus 1. So you would have to use that formula here, generate your initial term, and whatever you get for the end term, you'd put it equal to the first term, find what N will be, and the same process for the last term. So it's the same process, right? Let's keep pushing. So Annalie, I'm gonna call for help, right? The sequences below are either arithmetic, geometric, or neither. State the type of sequence in each case and justify your answer. All right. So, Annalie, you're gonna help me with part 1. What does it look like I have to do to get each consecutive term?
Multiply by 2.
Right. So you're seen as a AP or a GP?
A GP
Right. Now, mathematically, if I want to verify that, I need to prove it have a common what?
factor. No.
Just to consider common ratio. We just typically, like throughout, we just say common ratio. Common ratio. So to find the common ratio, the formula is Tn all over Tn minus 1. The reason for this is because imagine if you had T3, and this one will be T2. You minus in 1. So it's the next term divided by the previous term. Right. So, and you can't just do it for one. Just remember that, Javon. You can't do it for one. You need to do it for more than one pair of consecutive terms. So, Annalie, choose 2 consecutive terms for me.
Oh, 2 and 1 and then 16 and 8.
All right. So R is equal to 2 here. Then we could say 16 over 8. R is equal to 2. Since there is a Cool. Let's keep moving on. Kira, I would like you to help me with part B, right? So for part B, right? Yeah. Kira, for part B, you see in 2017, 14, 11, what I look like?
Yeah, minus and 3.
Right. So we need to figure out if it have a common difference, right? So we see that the common difference is -3, right? We see in that. Okay, so we need to prove that. So we recognize that is a Javon, you see in that question, that part B is that AP? Kind of hard to see, but is that AP?
Yeah.
Got it? Nice. So you add in -3 to get the next term. So Kira, remind me, what's the formula for common difference?
E R is equal to
No. You're talking about common ratio. So let me just get this thing clear, right? If you have a AP, you will have a common difference, D. If you have a GP, you will have a common ratio, R. Right. So, Kira, how would I find the common difference for AP? Forget the formula. How will you do it?
it would just be the number divided by the difference.
Number divided by the difference? No. In an AP, there's no multiplication or division. In an AP, there's just addition or subtraction. So, Kira, you told me -3, right?
Is that so?
Yeah, that's okay.
Right. So, Kira, you told me -3. So, what would I have to do to get -3? All right. So, Kira, I want to show you, right? If you have a AP, you recognize as an AP, then the formula to find the common difference is the next term minus the previous term. So, Kira, pick our next term and divide it by the previous term.
Pick an next term and divide by the previous one.
Right. So like a term that's ahead versus a term that's behind it.
20.
So like, no, like let me give you an example, right?
Okay, like 8 divided by 2.
And
No, 8 divided by 4. Sorry.
wait, we looking at question B. I just drawing an example with question A. So Kira, when I talk about consecutive terms, this is what I mean. I mean like two first, then 1. So I'll give you an example, right? Over here, it would be 17 minus 20. Because 17 is after 20. Kira, let me just try to clear up the confusion, right? So again, in a GP, you have a common ratio, and that deals with multiplication or division. In an AP, you just have subtraction or addition. So Kira, in part B, and you can see you had a -3 to get the next term.
Yeah.
So we need to prove that. So how are we going to prove that? To prove that, you're going to take consecutive terms and subtract them from each other. So you'd say 17 minus 20, right? 17 is a term after 20, so that's why I say 17 minus 20. Give me another example. So 17 minus 20 is -3. Give me another pair of consecutive terms.
14 minus 17.
Right. 14 minus 17. What is 14 minus 17?
-3.
Right. So therefore, the sequence is an EP. Right. Amy, help me with part C.
Yeah. Okay.
Amy, what do I look like?
Neither.
It look like neither, right? So for us to prove that it's neither, I need to invalidate both cases. So in other words, I need to show I do have a common difference and I do have a common ratio. You understand?
Yeah.
So first of all, we start off to try to find for a common ratio. If we were trying to prove it had a common ratio, how would I do that?
You would, I could see the formula and then what I would use.
Sure.
So, it would be Tn plus 1 over Tn.
Okay, I feel like that'll be easier to understand versus Tn over Tn minus 1. So I will change it up. I feel like I'll go understand a little more. Yeah. Kira, you understand this a little more? So you can see it here that this is the next term and this is the previous term because they're adding one. Okay, Kira, like, is it confusing you? Can you tell me?
I think I understand this one more.
Okay, no problem. No problem. Yeah, that easy. That more intuitive, right? So Kira, if I ask you what term is this, we can tell me. Term 1, term 2. What term is that?
Term 1,
What is this?
term 2.
Term 3, so on and so forth, right? So understand what this means. This means that if I say n is 1, then this could be term 2 because 1 plus 1 is 2, and this could be term 1 because it's just n. So it's the next term divided by the previous term. Right. So Amy, tell me, R is equal to Tn plus 1 over Tn. Right?
And you could put 5 over 2.
5 over 2. Okay, wait. Kira, tell me another pair I could use to figure out the other common ratio. So what's another pair I could use, Kira?
Um, 10 divided by 5.
10 divided by 5. Is this what you mean? Tell me that's what you mean. Yeah or no?
Yeah.
Yeah, that's correct. 10 over 5 is equal to 2. Kira, does 5 over 2 look like it's equal to 2?
No.
No. So is this a GP? Does it have a common ratio?
No.
No. And just to be sure, Kira, tell me one more I could do. So like tell me something over something. So like say 5 over 2. So give me another pair.
17 over 10.
Right. So in doing this, you're seeing that it does not have a common ratio. When we say common, we mean something that is same throughout. So this can't be a GP. It's not a GP. All right. Amy, let's check if it's a AP, right? So the formula for an AP would be D is equal to Tn plus 1 minus Tn. So Amy, tell me, D would be equal to,
We could say 5 minus 2.
right? 5 minus 2. 5 minus 2 is
3.
all right. So Javon, give me a pair that I could use to figure out the common difference. Another pair.
For C,
Yeah, for C.
5 over 2.
5 over 2. Wait, so Javon, we're trying to prove that is neither. So if you're trying to prove that something is neither, you have to test and see if it have a common ratio or if it have a common difference. So we've already proved that it do have a common ratio because none of them was the same. So it can't be a GP. So now we're testing to see if it's a
Oh,
right. So our AP just deals with subtraction. Just
yeah.
subtract.
Okay, well, 10 minus 5.
10 minus 5 is
5.
give me another pair.
17 minus 10.
Is the difference the same throughout?
No, so it can't be a AP.
So is neither. So guys, you have to do this in the exam, right? If they ask you to prove that something is neither, you have to do both cases. You have to prove that it's not GP and it's not an AP. Keep that in mind. Right. So let me do a little recap, right? Let me do a little recap. AP stands for arithmetic progression. And Javon, in an arithmetic progression, how are the terms linked together through a what?
A common difference.
Right. So you have a common difference. To find the common difference, you're taking the next term and minusing it from the previous term. So it will be Tn plus 1 minus Tn. So you understand that. If you had so this could be like the third term minus the second term. So that makes sense. Tell me if you're okay with that.
Yes, sir.
All right, good. If you need to figure out the general formula, it's going to be A plus n minus 1 by D. Good. So this is what we learned so far. For GP, Kira, what's the formula for a GP? And what does a GP have?
Is
So our AP has a common difference. What does a GP have? A common what?
ratio.
Right, a common ratio. Because Kira, a GP, the terms are linked together via multiplication. A quick example is like 2, 10, 50. So they get the next terms there, I would have to multiply by 5, right?
Yeah.
So to figure out, I would divide like 50 by 10, 10 divided by 2, so on and so forth. So that'll be Tn plus 1 over Tn. And what's the general formula for a GP? Just remind me.
Tn is equal to AR n minus 1 to the power n minus 1.
Right. We need to discuss what A is, N is, and D. What is A, guys? A is the what term? What is A? Annalie, what is A? In
The
both.
first term,
Right. A is always the first term. D, what does D stand for in the AP?
difference, common difference.
Right. And R stands for common ratio. All right. Let's move on. All right. So, Annalie, I want you to help one question to the two, right? So give it a read.
An arithmetic series has first term 12 and a common difference 3. The 20th term is the final term in the series. Find the value of the 20th term.
Okay. So they are telling us it's an arithmetic series. So immediately, what formulas we know are associated with an arithmetic series?
Tn equals A plus n minus 1 by D.
Right? If I wanted to figure out the sum up to the nth term for an AP, how would I do that? What is the formula for S of n?
N over 2 by A plus Tn.
Right. So you are correct, right? But I prefer to write it like this. Right? You didn't learn like this in school.
No.
Oh. It's the same thing. It's the same thing. Right? I can promise you it's the exact same thing because if you look at the general formula here, right? You could do some modifications and it's more or less the same thing. So that's why you see in Tn inside. You'll get the same exact result. I assure you, you'll get the same result. Yeah. Amy, aren't you familiar with this sum S of n formula?
Yeah.
Yeah. But Annalie, if you're familiar with the other formula, you could use it. I have that formula listed as well in the formula sheet, so it's whichever one you're comfortable with. Right. Annalie, in addition to the formulas we know, what information are they giving us?
A is equal to 12 and D is equal to 3.
Right. And they're saying that the 20th term is the final term in the series. Cool. So they want us to find the value of the 20th term. So if we want to find our nth term, what formula would I use?
The first one.
Right. Jovan, tell me if you understand that. In part A, they are asking us to find the value of the 20th term, which comes like the nth term. So whenever you want to figure out the nth term, you use T of n. That would tell you what the nth term is.
Yes, sir.
So Jovan, what are we substituting for n over here? In part E, what are we substituting for n?
20.
Right, because we want to go up to the 20th term. We want to see what the 20th term is. So Annalie, tell me what to write. T what?
T20 is equal to 12 plus 20 minus 1 multiplied by 3.
Right. And that's going to be equal to 1957. That's going to be 69. Just verify that. See that correct?
Yeah.
69. Okay, good. So that's the answer for the first question. Let's move on to part B. So Javon, which formula do you think I should use to figure out sum up to the 20th term?
The second one.
Second one. And again, I'm replacing n with 20. What formula are you more accustomed with? N over 2 by 2a plus n minus 1d, or n over 2 by a plus t of n?
Nah, the one you have.
Okay.
Yeah.
So Kira, that means you'll learn it using a plus t of n too, right?
Yeah.
Okay, well, you get the same answer. That's okay. So Annalie, let's rock it with your formula, right? And see what happens. So we have S of 20, and make sure I don't your formula. So you are telling me S of n is equal to n over 2 by a plus t of n. Okay. And the formula we are accustomed with is n over 2 by 2a plus n minus 1. Okay. So Annalie, you remember what I told you that you could do some modifications and prove that this is equal to this?
Yeah.
Like it really is, 2a, and I can write 2a as a plus a.
Yeah.
And then if I do that inside the brackets, I will have a plus n minus 1 by d. And so I could group this together, and that'll be t of n. And so that's how you get the a plus t of n formula.
Oh, yeah. I understand.
Yeah. So they're equivalent. Quick maths go show you it's equivalent. Quick maths. All right. So let me verify both formulas. So Annalie, I want you to do part B, and I'll do the other formula with the class, right? So you and Kira could do part B using the S of n formula for T of n, and we'll do it with the other formula. So, Javon, anyway, you see n, you're going to replace it with 20, right? So we're going to say 20, and that's going to be 20 over 2. What am I going to write? Tell me what to write inside.
2 multiplied by 12 plus 20 minus 1 by 3.
Right. So 2 divided by 20 is 10. I mean, 20 divided by 2 is 10, right? And then 2 by 12 is 24. And 20 minus 1, 1957. You should get...
I get 10.
5, 6. No, what's the end? You're supposed to get 5, 6, 7, 81. 81. So that'll be 810. That's what you got?
Yeah.
Okay, good. Ladies, y'all got 810 as well, right?
Yeah.
Nice. So you would have to find for T of n first. So did you all find for T of n on the outside and then plug it in, or did you all find it inside the equation? What did you all do?
Outside.
Okay. So on the outside, you could say that T of n, you write back what T of n is equal to real quick. So T of n would be equal to E plus n minus 1 by 3. And we want to find T20. So that's, well, we already know what T20 is. We already know what that is. In the previous part, we found that. So Kieran, and Annalie, I didn't even have to find it because T20 already there. Are you seeing that? Did you all see that? Annalie,
Yeah.
did you find back T20 or did you use C69?
I used back B69, but I had it written down before.
Okay, good. So that's gonna be 20 over 2. 20 over 2. Gonna be 12 plus 69. And let's see if it works out. So Javon, what is 69 plus 12?
81.
Right, so you get the same answer. Right. So those are your answers. Is anybody confused at all? Javon, tell me if you're confused.
No, sir, I good.
So Javon, anytime you read a question, if you're saying what the series is, I want you to immediately write down the formulas associated. So with an AP, you have the T of n formula and you have the S of n formula. That's about it. So write down the formulas and just know you will have to use either one of them. If this is a GP, write down the formulas. For a GP, you have a bunch of formulas. You have the general term formula. You have the sum where R is more than 1, where R is less than 1, and you have the sum to infinity formula. You have quite a lot there. All right. So cool. Let's move on to question 33. So Amy, read question 33 for me.
The sum of the first 5 terms of a geometric series is 93.75. The first term is 7.5 and the common ratio is 2. Verify the sum using the formula and determine the fifth term.
All right. So Amy, upon reading the question, what do we immediately recognize? And it's a what?
Geometric series, yeah.
Right. So tell me one time. What are the associated formulas with a geometric series?
S of n, which is a in brackets r to the power n minus 1, yeah, minus 1 bracket, over r minus 1.
Right. So Amy, do you find that the formula sheet is convenient?
Um,
Or like you haven't used it yet?
It alright. I don't know. I feel
Right.
like the
You just
only thing it really okay for is if you're doing trig proofs and it have the 2 formulas they give you,
okay.
you know? Yeah.
And you have another formula. What's the other formula? When
Um,
it's less than 1.
A in brackets 1 minus r to the power n over 1 minus r.
All right. Javon and Annalie, I think I showed my students this already, but all I ever wondered why, if R is more than 1, is R minus 1, and if R is less than 1, you had to say this. All I ever wonder, like, you know why? Javon, you know why?
No, sir.
Okay, Javon, if your answer is less than 1, right? Let me just say R is a half. If you use this formula, what is a half minus 1?
Um, negative a half.
Right. So that is why you just switch it so you don't get a negative number. So if R
Oh,
is less than 1, the 1 has to come in front so that you don't get a negative number when you subtract. So you understand what I mean, right? And the same reason here. If R is more than 1, give me a value that's more than 1.
2.
if I plug 2 into this formula, where's 1 minus 2?
-1.
Right. So that's a little hack. So they're gonna know which one to use. Annalie, did you know that before?
No.
No, well, now you know. You could always just check back that fast. The denominator should always be a positive number. Always. Right? Amy, let's continue. So we have these formulas. What are the other formulas we have?
To find the n term,
Right? So T of n is equal to
a by r to the power n minus 1.
awesome. And are they asking us for sum to infinity in this question?
No.
Nah. So we good. We should be good here. So the sum of the first 5 terms is 93.75. The first term is 7.5 and the common ratio is 2. So Amy, which formula do you think I have to use? This formula or this formula? 1 or 2?
1.
I have to use 1. Javon, why is Amy saying that we have to use formula 1?
Because the R is more than 1.
Where's R, Kira? Kira, any question? What is R?
The ratio.
Right, but what is R? What was R given to be?
2.
2. Cool. So we're definitely going to use this one. And Amy, do we have all the other pieces of information we would need?
Yeah.
Right, so A is equal to 7.5. R is equal to 2. And S of 5 is equal to 93.75. All right, so Amy, tell me what to do. Let me see if you have this.
Well, they said to find the sum to prove that is 93.75. So you could put S of 5 is equal to 7.5 in brackets 1 minus 2 to the
Wait,
sorry, R, sorry, my bad. I mean 2
2.
to the power of 5 minus 1. Yeah, over 2 minus 1.
Right, so Javon, you see what I'm talking about, right? When you plug it in, the denominator should always be a positive number.
Yeah.
Always check to see if whoever you're doing that you're getting a positive number in the denominator. If you're not, you're using the wrong formula. Right. So Amy, plug it into your calculator and let me know what you're getting.
I was doing it and I didn't get back the same thing. I get 232.5.
Let me check. Okay, damn, I'm getting 232.5 as well. So there's an error with this question. Or there's an error with this question. So let me just make the appropriate changes. Right? So the sum, I'll just change this to 232.5, right? And Amy, 232.5. We're gonna call it that because we're getting that. All right. Annalie, Kira, Javon, just verify this again, 232.5.
Yeah.
Okay. So, Amy, the next thing they're saying, determine the fifth term. Determine the fifth term. How would I determine the fifth term?
By using the formula for A of n. Well, you have T of n.
Right. So I would say T of what?
5 is equal to 7.5 by what's the ratio? 2 by 5 minus 1. And it's supposed to get 120.
1 to 1 what?
120.
Exactly 120.
Yeah.
Okay, good. All right, so Javon, let me know if you understood everything I did here, like everything.
Yes, sir. It's good.
Okay. So Kiara, let me know if you understand everything. Is there anything you want me to run through or?
No, I understand.
Okay, so Kiara, and for everybody that's in class, guys, anytime while they work in a question, if they give away what kind of series it is, here what, underline it and put on all the formulas you're gonna need one time. One time. The T of n formula is the formula you would use to figure out for the nth term. It could be the 20th, it could be the 19th term, it could be any term. And anytime you see sum, take the S of n formula. One time. Right. Okay, so Kiara, let me do a question. So Kiara, read question to the fourth one.
Determine whether the following geometric series is convergent or divergent.
Right. So let me just do a little recap real quick, right? Kiara, just by looking at this, does it look like it's gonna converge to a very, very small answer? Or does it look like it's gonna diverge? Do you know the difference between converge and diverge?
Yeah,
What are you looking like? Conversion or a diversion?
convergent,
Right. Because the value is getting
smaller.
right. So convergent means that values are and what does divergent mean?
The value is getting bigger.
Right. Now, if the values are getting smaller, right? Do you all think that the common ratio would be a fraction or it'd be a whole number? What do you all think? Kira, what do you think? If it's conversion, do you think the common ratio is going to be a fraction or it's going to be a whole number?
A fraction, probably.
Right, it's going to be a fraction. Is equal to, so this is what it will be. So it'll be a fraction. Javon, if you're confused by that, let me show you something real quick, right? Real quick. So Javon, if I have a quota, right? And I multiply, actually, let me start with a whole number. Let me just say we have 4, right? Where is 4 by a half?
2,
2. Where is 2 by a half?
1,
Where is 1 by a half?
half,
A half by a half?
a quarter.
Okay. Anytime you multiply by a fraction, what happens to the values as they go down the line?
It getting smaller.
Again, smaller and smaller and smaller. So in this example, what would be the common ratio?
2/3.
2/3? No, a half.
Oh, and that one, yeah.
Yeah, because okay, understand where you get 2/3, but in this example, it will be a half, right? So generally speaking, anytime we dealing with series and it's convergent, the common ratio is going to be a fraction. If it's diverging, then the common ratio will be more than 1. Give me a second, guys. Right. So let's keep pushing. So now that we understand the differences, we can easily prove if something is convergent or divergent. So Kira, let's go. So Kira, we know it's a geometric series. So how would I figure out what links the terms together? Would it have a common difference or would it have a common ratio? Tell me, Kira, would it have a common ratio or a common difference?
It would have a common ratio.
Right. Anytime you see geometric series have common ratios. Common ratios. All right. So you understand that. Do you remember the formulas to figure out for R?
Yeah.
Okay, so it's I'll start you off. Tn plus 1 all over.
Tn plus 1 all over
So Tn plus 1 is the next term, what will be the original term?
Tn. So just
Tn.
put Tn plus 1 over Tn.
Correct. So when you find any common ratio, you're going to give me consecutive terms. So, for example, the third term divided by the second term. The second term divided by the first term. That kind of thing. So what's the second term?
12,
Right? So you can say 12 divided by,
18,
right? What is 12 divided by 18?
2/3.
Right? I want you to just verify with another pair of consecutive terms.
8 divided by 12.
Right? And you should get 2/3 again. Right. Suppose you get 2/3.
Yeah, that.
Right. So this is the statement you need to put. Since R, I need to put a range. Since R is less than 1 but more than 0, Javon, you remember this notation from yesterday? Anytime you see that notation, it means in between two values. Remember?
Yeah.
Okay, word. Right? So anytime you have this situation, you need to write that the series is convergent. Right? So Kiara, keep that in mind. So Kiara, if you got a value for R that was more than 1, you would say since R is more than 1, the series is divergent. Right. So Kiara, since we recognize it's a convergent series and the value is getting smaller, Kiara, any values would eventually get so small, it wouldn't have any significant value.
Yeah, probably.
Right. So we proved that it was convergent. Now we need to figure out its limiting sum. What do you all think, Kiara, what do you think we'd have to use to find the limiting sum? What formula do you think I would have to use to find the limiting sum?
Would it be? It's only formula sheet because I see one on the formula sheet that.
Yeah, have a formula in the formula sheet for this. Think about it, Kiara. Limiting sum. Hear what I'm saying? Eventually, the answer gets like the next term to add gonna get so small. So like eventually, maybe you might have to add a term that's like 0.00000000001, whatever the case may be. And so eventually, you're gonna end up with a sum that would just remain the same. So I'm talking about the sum to what? If I keep on going down the line, like I just keep on adding terms down the line, we're talking about sum to what? If I just keep adding indefinitely, just keep going, that's sum to what?
Infinite, that it will be.
Right, sum to infinity. So anytime you see something like limiting sum, or find its limit, or find the value is convergent to, you have to use the sum to infinity formula. Right? And tell me that formula, Kira.
S infinite equals a over 1 minus r.
Correct. Right. So we're going to use that formula. So Kira, tell me, if I want to find the sum to infinity, right? Tell me what I'll be equal to. So that'll be E all over 1 minus R. So tell me, Kira, what is E? In this question, what is E?
Um,
Remind me, what is A?
A is 18.
Right, Kira, A is the first term. A is always the first term, and R is the common ratio. So, Kira, make a note of that. A is the first term, and R is the common ratio. So, Kira, again, if you look at the sum that was given, what is the first term for that,
18.
right? And what is the common ratio we found?
2/3.
Correct. So we're gonna say 18 all over 1 minus 2/3. So plug that into your calculator and let me know what you're getting. Supposed to get like 54, I think. Let me know if you're getting 53.
Yeah, 54.
All right, good. So that's the answer there, right? So Kira, let's run through it one more time. So Kira, if you have we start off with GPs, right? If you have a GP, that means you're gonna have a common what?
Ratio.
And common ratio, what letter represents that?
R.
Capital R, common R, tell me. Be specific.
Common R.
Right. If it's convergent, that means R is a what? R has to be a what?
A fraction.
Correct. R has to be a fraction. If it's divergent, has to be more than one. Nice. If they ask you to figure out the common ratio, you feel confident that you'll be able to do that?
Yeah.
Okay. And anytime you see sum to infinity, you use the formula A over 1 minus R. Or if they ask you to figure out what value it converges to, sum to infinity. So Kira was saying, right? So Kira, anytime you notice that the value is getting smaller and smaller and smaller, just know you're gonna have to use this formula. Just know that. Anytime you see the values getting smaller and smaller, right? And just to recap, what does A mean?
First term.
Right? And R is common ratio. Nice. So Kira, I want you to help me with this one as well. Don't worry, Kira, I have my eye on you. I'll make sure you pass on maths. So Kira, in this question, do you notice the values getting smaller and smaller and smaller?
Yeah.
So without even looking at what they want, what we know we ought to use? What we know we ought to use?
The common ratio.
Well,
Oh, the sum to infinity.
right. And remind me, what's the sum to infinity formula?
A divided by 1 minus R.
Right. Do I know what A is?
Is the first term. Should be 80.
Do I know what R is?
No.
So I could find for R. Tell me fast. What would R be equal to? Tell me the formula first.
Tn plus 1 over Tn.
Right. So give me a pair of consecutive terms.
40 divided by 80.
What is 40 divided by 80?
A half.
Give me another pair of consecutive terms.
20 divided by 40. And you'll get a half too.
So can we confirm that it is a GP?
Yeah.
Right. And so I'm going to say 1 minus.
1 minus a half.
Right. Annually, you notice what we're talking about with the denominator, right? You notice it will be positive. In all instances, when you apply a GP formula correctly, the denominator is supposed to be positive. Always. It's supposed to get 160.
Yeah.
So annually, like this stuff easy, right? I'm gonna if you following, like you understand and everything. I'm gonna
Yeah, understanding.
okay, will right. This one is a little tricky question. So Kira, I'm gonna keep you on the field, and your friends could assist. So Olia on standby. Olia could assist Kira, but Kira, I think you can figure this out. So Kira, read question 36 for me. Be very careful with this question.
A car depreciates. Depreciates?
Yeah, depreciates.
Okay. A car depreciates in value by 20% each year. It was bought for $60,000. Find the value of the car after 5 years. Calculate the total depreciation over the 5 years.
Okay.
Depreciation.
So,
Sorry.
Kiara, you know how you gonna handle a question like this? These kind of questions just come.
Well, if the original thing was 60,000, and that would be the first thing, would it?
Yeah, it would be 60,000 initially.
And then, well, it decreasing by 20% each year, so we would have to find 20% of the 60,000.
Right? So, well, let me explain a catch in this question, right? So, Kiara, they're saying that the car depreciates, right? So, as soon as you buy that car, it started to depreciate. So, let me just say you buy that in January 2025. By December 2025, what's the worth of that car?
20% less.
Right. So, there's a trick here, but I'm going to show you all several ways to get this question correct. Several ways. Right. Amy, are you making the connection that you could use the formula for compound interest to figure out this formula? Can you see it?
Yeah.
Yeah, you could use the formula for compound interest, which is A1 minus R to the power N. That's true? Is it? I know
Yeah.
some people they say R over 100, but if you convert the R to a decimal, it will just be 1 minus R. Yeah.
Mhm.
But I'm gonna show you several ways you could do a question like this. So Kira, here what I want you to do. I want you to find 20% of 60,000 from her. Right? So Javon and Annalie, you all could try the question in the meantime.
I get 12,000.
You get 12,000.
Yeah.
All right. So, all right. So, all right. And Kira, would you say that this is year two?
No.
Wait, we're making a little mistake, right? A little mistake. So, Kira, in the first year, so this would actually be year zero. This would be year zero. That's like when you now buy the car. A year didn't pass as yet.
Mm,
After 1 year, what will be the cost of the car if it decreases by 12,000?
60,000 minus 12,000, so that will be 40,000.
Right. So at the end of year one, it's going to be 60,000 minus 12,000. So that's going to be 48,000. Okay. Um, and Kira, what would I do next? What would I do
Um,
next?
yeah, you're fine for the rest of the years? Well, until 5 years pass?
Yeah. But that's like a really repetitive process. So,
It would just, year 2 would be 36,000.
nope, nope,
No?
nope. That's a
Oh, no, wait.
that's all
That
this
would be,
you know.
that would be 60,000 minus, just no, wait.
No. Here what happened, right, Kira? It's saying it depreciates in value by 20%. So the depreciation is not
Also, the
value.
48 will think by 20% too. So you had to
Right.
find 20. Okay.
Annalie, can you make the link that this is effectively the same thing as happening in compound interest?
Yeah.
So you could use the compound interest formula and get your answer. Actually, you could. Right? So like I said, I'm gonna show you a bunch of ways to do it. This is a manual approach. So Kira, find 20% of 4,800 for 40,000.
9,600.
Javon, would you be one of those people in the exam that would find 20% of 60,000 and then just keep minus and 12,000 going on the line? Would you do that? Be honest.
Honestly, yeah.
Yeah. But,
If it's a small number, like 5 years, yeah.
but you see that wrong, right? Because watch. They're saying it depreciates by 20%. Are they giving you a value? Are they telling you what value it depreciates by?
Yeah.
No, what are they giving you instead?
They giving you the value at which it depreciates by, well, 20%.
Right. So every year it losing 20%. So if when you now buy it, it was 60,000. So at the end of year one, it'll be 48,000, 20% less, right? And at year two, at year two, it's gonna be 20% of 48,000 less. You understand what I'm saying?
Yeah.
Right. So don't be one of those people that are making a mistake. So I'll show you now this approach. I'm gonna show you like three approaches because I know everybody's think differently. So Kira, when you find 20% of 48,000, we get
9,600.
9,600. So
Yeah.
what will be at the end of year two?
38,400.
And Kira, well, you could do this to your heart's content until you end up at your answer. But I find this like
Mm-hmm.
real repetitive. So when you minus 9,600 from 48,000, what you get?
38,400.
38,400.
Yeah.
All right. So Kira, in year two, it'll be 38,400, right?
Yeah.
All right. So Kira, here what we could do, right? Here what we could do. And I didn't lose you anywhere, right? If I
Mm-hmm.
fully well understood everything I did so far. Javon, did I lose you anywhere? Come on,
No,
Javon.
sir.
No, right now it's feeling like I'm a maths exam, right? It's feeling like a maths exam.
Yeah.
So let me spice things up a little bit. We Annalie and Amy, I feel like all they're itching to say 0.8. I feel like all they're itching to tell me. And you could just say 0.8. Wait. Amy, are you itching to say that?
Kinda.
Kinda. Wait. Well, I showing everybody the easiest way. So Javon and Kira, I'll understand how we come up with these terms. So Kira, if we come up with these terms, can we figure out a common ratio or a common difference?
Yeah.
So Kira, do you think it'll be a common ratio or a common difference? Do you think this is a AP or a GP?
A GP.
Right, because to get the next term and you're multiplying by something and then you're minusing it. So it's definitely a GP, right? Plus is a percent, it's definitely a GP. So let's verify that. So if I wanted to find the common ratio, I would say what? What would I do to find the common ratio, Kira?
Tn plus 1 over Tn.
Right, so give my example using this.
I was wondering, wait, I will have a question, right? We use here 0?
Yeah, 0 is the initial amount. You have to use year 0.
Okay. Okay. So it would be like, an example would be like 48,000 divided by 60,000.
What are you gonna get?
Um,
I don't know if I know
4
this.
fifths.
4/5?
Yeah.
Some of us are decimal.
0.8.
Okay. I don't know if I noticed, right? But question, just like this come last year. Just like this come last year. I don't know if I saw that. Right? Kira, let me try another one. You want to pay off up to another pair.
38,400 divided by the 48.
Some away again.
4 fifths too.
So that is 0.8 as well, right?
Mm-hmm.
So since it has a common ratio, meaning that the ratio for consecutive terms is the same throughout. And we know is our what? What we know it is, for sure. For sure, what it is. What is it, Kira? For sure, what it is.
A GP.
Right, it's a GP. So Kira, do we know what the first term is?
Yeah.
Right? Now, this is where things get a little trickier. We're going into murky waters here. Murky waters. So, Javon and Kira, tell me if I'm losing all that, right? So, Kira, technically, what is the first term? What is the first term? Like
Year one.
after the depreciation.
Year one.
Right. So what we're gonna do, right? What we're gonna do? Technically, A is year one. So A is technically 48,000. So that's going to be, and Kira, tell me, if I want to figure out what's going on.
The cat trip on something and hold on.
And
Anyways.
if I want to figure out the value in after 5 years, what formula would I use? We're talking about the what value?
The
Tell me, like, it's not complicated. After 5 years. So year one is one term, year two is another term. So what term we trying to find?
or the sub
What term?
year two is the
First term. Year two is the second term. Year three is the fourth. Year three is the third term. Year four is the fourth term. So year five will be the
15.
right. So we're trying to find for the fifth term. What formula would I use to figure out for the fifth term? What formula do I use anytime I'm dealing with term? Term. For GP. Look at the formula sheet. What formula do you use if you want to figure out for the nth term?
It would Tn equals it would it really Tn equals the air and minus 1.
Yes, because you use that to figure out for the nth term. You have to find for the 5th term, right? So the formula you're thinking about is T of n is equal to AR to the power n minus 1. We want to find the 5th term, so I'm going to replace n with. What am I replacing n with?
5.
Right? What is the first term?
48,000.
Right? My common ratio is?
Use the decimal?
Yeah, 0.8.
Okay.
It don't matter. Right? So what power?
5 minus 1.
I plug into a calculator and I'm gonna watch it.
I get 19,660.8.
19,000.
660.8.
Amy and Annalie, did you all get this answer?
Yeah.
Yeah. Amy, did you use the compound interest formula and get the same answer?
Yeah.
Okay, cool. Javon, did I lose you anywhere in this question?
No, sir.
No? Okay. Now let me show you a simpler way you can do it. Much simpler way. Still using the formula, but slightly different way. Javon, if I was saying the car depreciates by 20%, what that would mean, what would the value of the car be then?
Wait, so I have a question.
Tell me.
Yep. Well, the reason you didn't use 60,000 is because 48,000 was the first year, right?
Right. After the first year, well,
Yeah.
at the end of the first year, it was 48,000.
Because initially I do 60,000 at first, but then yeah, I changed it.
So you wanna Here what? Let me do the full working and see if it's correct. But before we do anything, I want to show you something logical. If every year the car losing 20% of its value, what percentage of the value is going to remain every year?
80%.
80%, right? So then watch this, watch this fast. If I want to figure out here, and I just had to multiply 60,000 by 0.8,
Yeah.
48,000 by 0.8, 38,400
Yeah.
by
Oh,
0.8.
yeah.
We could keep doing this. I want you to count how much 0.8s I use. Wait, if that's the case, it might have a little error here, but let me see how it will work out. Let me see what happen,
5.
right? Let me see what happen. So, Javon, a way to find 0.8 at 38,400.
30,720.
30,720.
Yeah.
Okay, find 0.8 of that.
24,575.
Right? Find 0.8 of that.
19660.
So are we correct?
Yeah.
Yeah, that's the answer we get.
Oh no, point 80.
Yeah, yeah. So watch that. Even if you don't know compound interest, even if you don't know APs and GPs, you could still do this and get your answer. Still do it.
Yeah.
Now, the reason why I generated terms is because I know some of you might not even see the 80%. So I show you that you can generate terms, you can find the common ratio, and you will get 0.8 because and that's what we get for the common ratio. Like when we generated these two terms, and when we divided, we got 0.8. And you see
Yeah.
that? Right. But if we think a little harder, we could realize that if the car losing 20% of its value each year, then at the end of each year, it's gonna remain with 0.8 of its value. And you can make that assumption. And you
Yeah.
understand that? Yeah. And so if that is the case, all we had to do is just multiply like this down the line. And this is like the easiest way you could do it if you don't know any fancy maths.
Mhm.
So you're 100% okay with this question. I have a question just like
Yeah.
this in 2024.
Yeah, good.
Okay. And the reason why I did not use year zero is because it's starting, technically, the depreciation starts at 48,000. So 48,000 was the first depreciation. The second depreciation was 38,400. The third depreciation was that, the fourth, and then the fifth depreciation. So annually, you understand what I'm saying? You understand all the methods?
Yes, sir.
Okay, word. Did you think about it like this so that at the end of every year, I have 0.8, the value? Did you see
I
like,
didn't catch it at first.
but like now that you catch it, it's like, oh,
Yeah.
yeah, right? And I think some of you all would not make the connection that this is year zero. Annually, would you have had said 60,000 is year zero?
No.
But think about it. When you buy the car initially, did any time pass?
No.
Nah, so that's technically year zero. It's only at the end of the year, it will be year one, it will mark year one. And so the car will be 48,000 by then. Right. So I hope everybody understand that. Let me show you another method. Anytime you have questions like this, where the change is a percentage of the consecutive term, you can use this formula. And this is like the compound interest formula. So this over here, this is method one. You could generate terms, find the common ratio, but you really don't have to do that. If you want to find the common ratio, just minus 100 from 20%, 20% from 100, and write it as a decimal. That's it. Amy, you fully understand what I'm saying, right? There's no room for confusion. Come on if you understand.
Yeah, I understand.
Kiara, I want to make sure you're not confused, right? So Kiara, you're there, right? Kiara, I'm gonna let you
Yeah.
know.
Yeah, sorry.
Kiara, you see how we do all of this madness? and then we find the common ratio.
Yeah.
We didn't have to do that. You know why we didn't have to do that? Because, Kira, if let's say the car depreciating by 20% each year, then how much value will be left after the 20% you take away? Kira, listen to what I'm saying, right? If it's depreciating by 20%, depreciating, I mean minus and also minus and no adding.
Minusing.
Right. So if the car losing 20% of its value, what percent of its value does it remain with? Kira, it kind of scared me, you know.
No, actually,
I promise it's not hard. Think about it. Think about it. What is the full percentage? What is the full value? What would you represent the full value using?
the 60,000.
Right? And that'll be what percent? What percentage do we use to represent the whole thing, like the original? Okay, Kira, if you do rel getting, was the most amount of marks you get in your AdMaths test? Right?
100.
And if you get 100 over 100, that means you get 100%, right?
Mm-hmm.
So what percentage is the maximum percentage here?
100.
Right. So in year zero, it would have 100% of its value. And then it loses 20% of that. So what percent remains?
80%.
Right. So every year, the car is going to remain with 80% of its value. You know what I'm saying?
Yeah.
Right. So then what that means is the common ratio is 0.8. Because every year you're going to multiply by 80%. What? You're going to multiply by 80% of this to find how much you could lose if like you take away 20%. Right? You understand what I'm saying?
Yeah.
And it's the same process over here. If I want to figure out how much it'll be after it loses 20%, I will find 0.8 of this. And so you know how to do all of this. You know how to do all of that to find R. You really don't. You can look at it and figure out that R is 0.8. So I'll write that down. I'll make a note about that. All right. So, Javon, in the exam, are you going to do all of this madness, or are you just going to look at it and figure out what R is? You gonna do all that, or are you just gonna look at it and figure out, well, okay, it depreciated by 20%. That means you remain with 80%, so that is 0.8. What you gonna
Yeah, 90.8.
Yeah, you're not gonna waste your time doing all of this. You just look at it. Okay, so guys, if it was appreciating, it would be what percent? What percent would it be then? If they say the car was appreciating in 20%, by 20% each year, what would you multiply by?
By 1/5.
Wait, Javon, what is appreciating mean?
Increase in
Right.
value.
So that means if 100% is your original value, then what percentage you add into that? So here I'm saying, right?
120.
Right.
120.
So it'll be 120%. And that's a decimal is?
6/5.
So 1.2. No, decimal I said, not fraction.
Oh, yeah.
That'll be 1.2, right? And that'll be 1.2.
Yeah.
Right. So then if the question come differently and instead it says appreciation, then all I had to do, instead of multiplying by 0.8, just multiply by 1.2. Because instead of it dropping value, you're adding 20% to the 100%, and that is 1.2. So every year it will be 1.2 of the original. Giovanni, understand what I'm saying?
Yeah, I understand that.
Right. Annalie, you understand everything I'm saying?
Yes, sir.
Okay, word. And Amy, I presume you understand everything I'm saying, right?
Yeah.
All right. So the easier way you could do a question like this is anytime, right? So anytime you see a percentage well, in this case, I would say D for depreciation. So it would be actually no, let me not say that. I would say so the amount will be the principal by 1 minus R to the power N. All right. So Javon, I showed you another method, right? Javon, well, obviously you see compound interest this year in the maths paper, and they give all the formula, hence, and they give all the formula for compound interest.
Yeah.
Right. So compound interest is the same concept as this question. So you could use this formula, right? So in the formula in maths, it is be R over 100, and it is be R over 100.
Yeah.
Right. But if we convert it into a decimal, do we need to put R over 100?
No.
No. Right? So just remind me, what was the initial amount of money?
60,000.
Right? So I'm going to say 60,000. Right? What was the rate as a decimal?
0.8.
Nah, it was 0.2.
Oh, yeah.
Right? Watch. Notice is 1 minus 0.2. So doing this formula doing everything fair.
Yeah.
Because what is 1 minus 0.2?
Negative 0.2.
Wait, what?
Wait.
Run that back. 1 minus 0.2.
0.8.
Right. Yeah. You see? They get is 0.8. So this formula doing everything for you. And where's the number of years we're going up to?
5.
Right? So plug that into the calculator and I'm on the way again. Amy, which method are you sticking with?
The compound interest is the faster and the least amount of working.
Okay, but if they specify to use the component, I mean, if they specify that you have to use the GP formulas, then you know what to do, right?
Yeah.
Okay, word. Yeah.
I got 19,660.8.
Right. So no matter what we do, we get any correct thing, right? Yeah. So Javon, anytime you're seeing they're talking about something as a percentage, rather than just giving you a value to add or minus, chances are you had to use this formula. So P is the original amount, or all you're going to know it as the principal value, right? P is the original amount. R is the rate as a decimal. And N is the number of years. So Kira, I feel like you should just use this formula and done. I feel like you should just use this one. This formula does do everything fair. Everything. Right? So Kira, this formula, check out this formula. This formula very sweet. Right. So let's continue. And we just have two questions and then we're going to move on to calculus. Oh, before I move on, I want to do two past paper questions. In the past papers, I had like some tricky questions I needed to do with all them. So I will do two past paper questions. Right. So, Amy, I didn't call you in a long time, so help me with question 37. So tell me, Amy, get the question I read.
An intern is paid 12 just now.
Okay. Amy, like you have a pet cat as well.
Sorry, no, my father just come home.
Oh, I see you
Yeah.
have a pet cat like Kiara,
No.
right?
Well, yeah, but he outside.
Oh,
Yeah. An intern is paid 1200 in the first month. Each month their salary increases by $250. A, how much will they be paid in the 10th month? And B, what is the total salary earned in the first 12 months?
Amy, is that AP or GP?
AP,
What tells you is that AP?
because it's increasing, like it have a difference, you know?
Yeah. It increases by a certain amount. Like,
Yeah.
unlike this question, in this question, they say it by a percentage. By a percentage, right? Notice in this question, it's an actual value. Javon, I want you to notice that, Javon, notice that. Over here, it's a percentage. A percentage. So every year you had to find a percentage. Or in other words, every year is by 0.8. Javon, you understand?
Yes.
But over
Yeah.
here now, they're telling you it increases by 250. So that means every month she gets her salary increasing by 250. So if they say an increasing by 250, that means what we doing to the salary every month? What we doing? Multiplying, we minusing, we adding.
The RN,
Right? So then where's the common difference?
you would be 250.
Right. Because it increasing by that amount. The common difference is like the linking term. So to go from one term to the other term, you have to add 250. Right, so we know it's an AP because it's saying the salary increases by a fixed amount. And that is 250. Right? Amy, did they give you any information on if so? Tell me what to write one time. So did they give me E?
Yeah, 1200.
Did they give me D?
Yeah, 250.
Right. If we want to figure out the amount of money in the 10th month, what formula do we use for that?
The A of N.
Right? A of N, T of N, the same thing.
Mhm.
Same thing. Right? And that'll be what? A plus,
A plus N minus 1 by D.
right? And we want to go up to what term?
The 10th.
Right? So we want to figure out the 10th term. So tell me what to write.
It will be 1200 plus 10 minus 1 by 250.
Amy, you think I could do in my head? You think I could do that in my head?
You could try.
The answer is 3,450.
Yes.
I've bought it. You know how I do that in my head so fast?
No.
I said 9 by 200 is 800. What I say? I say 9 by 200 is 1,800. And then 9 by 50 is 450. So that's 2,250. And then 2,250 plus 1,200 is 3,450. That's all. Right?
That's crazy.
One time. Come on, man. Awesome. Amy, you could do that. We telling me that's crazy. You could do that.
Why I cannot do mental maths.
You could. You could. You can. Trust me. Annalie, you could do mental maths like that.
I don't think so.
I think I'll just need to do plenty maths and eventually go a little develop the skill. You can just like see it. Right? So the answer is 3,450. Make sure I'm put the units, right? Put the dollar sign. Part B now. What is the total salary earned in the first 12 months? So in the first 12 months,
You would use the S of n formula.
Right. Because what is the hint there? That you have to use the S of n formula.
They say total.
Right, they say total. Over here. So Javon, in case you're confused about when to use the formulas, look at this, Javon. It's TH, th. And to have a formula for the nth term.
Yeah.
So yeah, anytime you see TH, you use the formula for the nth term. Right. So automatically, how you learn it in school? T of n or A of n?
T of n.
Okay, word. So that means you had to use the T of n formula. Some of all would learn like that. Some of all would learn like this. It's the same thing. Right. And if you see total, automatically that means sum. So automatically that means sum, right? And you're going to use the formula n over 2 by 2a plus n minus 1 by d. So let me roll. Yeah, so Amy, tell me. We want to find the sum to the 12th term. So that'll be 12 over 2. 2 by a, which is 1200. Plus 12 minus 1. And the common difference is 250. Amy, you think I could do that in my head?
Oh God, that would be impressive if you could.
That would be impressive, eh? That would be really impressive. Oh my God. Let me see, let me see. 11 by 250. I probably, no, I feel like that'll take me too long. That'll take me too long. That'll take me too long. Yeah, that'll take me too long, honestly. But let me see if I can still do it. Um, uh, that'll be 25. I have a question, right? Is 11 by 250, wait, is it 2750?
Yeah.
Okay, 2750. And so the inside could be 3150. No. Wait. 750. Maybe 5150, the inside. Would the inside be 5150?
Hold on.
The inside.
Yeah.
Okay, and so 5150 by 6. 5150 by 6. That'll be, so the inside is 5150, right? I have
Yeah.
a short-term memory loss. 5150. So the answer will be 39,000. Wait. Let me just think about that one more time. 5150. Is it 39,000?
You have the correct digits. It's just in the row.
3900. No, 3900. 3900. What's it? 3900.
Yeah.
Yeah.
Wait, no, it's 30,900.
Yeah, I get that too.
Oh God. Yeah. Oh God. I work it in my head. Alejandra Loma.
Yeah, the same numbers.
Why I did it wrong, boy? It'll be 5150. Yeah, because 150 by 6 is 900. And then 6 by 5,000 is 30,000. Yeah, 30,900. I don't know why I said that. Right? 30,900, right? I feel stupid now. 30,900. So everybody get an answer. So that's the answer. Cool. Let's keep moving on. Right? To the 8th. All right. Annalie, I didn't call you in a long time. Help me with question to the 8th.
Jane invests $1,000 at the start of each year in a scheme that grows at 5% annually. Find the total value of her investment at the end of 6 years, assuming each $1,000 gains compound interest from its start date.
Oh, so we could do over here. What would you do over here? Salma annually.
First, use the TN formula for a GP,
Say
and
use TN formula.
then we have to do the SN formula because they said total after.
Okay, well, I'm gonna read the question one more time. So Jane invests 1,000 at the start of each year in a scheme that grows at 5% annually. So if she invests 1,000 at the start of each year, so they say she invested 1,000 at the start of each year in a scheme that grows 5% annually. So in the first year, then that would be, should have put $1,000. And at the end of the year, that would be 1.05 of that. And so it would have a certain amount of money here. And what I'm thinking is the next year, she will invest another 1,000 into that. And then that will grow by 1.05. Let me think. So why did you say T of N? Let me hear. Why did you say T of N? Oh, wait, tell me, why did you use T of N? I'm not sure.
And now realizing it don't really make sense because they didn't tell us any
Wouldn't make
year
sense.
to find.
That would not make much sense. But the S of N formula still holds relevance. Yeah. But like, see if you understand what I'm saying, right? I'm saying that, so like in the question, they're saying Jane invests $1,000 at the start of each year. So is it like a one-time thing where it's like she put $1,000 one year and then she move on? Or like is she continuously putting in $1,000?
Continuously.
Right? So she continuously putting in 1,000 and it grows 5% annually. So at the end of the year, it will be 1.05 of the initial amount. Is that true?
Yeah.
Okay. And the saying find the total of her investment at the end of 6 years. So they're saying that she invested 1,000 at the start of each year. So let me try to understand this question conceptually. So let me just say we have January 2024. I'm giving all you a scenario. And I'm showing all you how I will do the question if I see it for the first time, because I've seen the question for the first time. I create the questions, but I'm doing it for the first time. So annually, in January 2024, she would put in $1,000, right? Some of that makes sense.
Yeah.
In December 2024, how much would that now be?
$1,050.
Right, $1,050. And they are saying that every year she invests 1,000. So that being said, in January 2025, how much money is gonna have in the bank?
$2,050.
Right. And so that's gonna increase by
5%.
right. So that'll be by 1.05. What would you get?
$2,152.05.
$2,150.05.
$52, yeah. And 50 cents, my bad.
All right. So this is year one. This is year two. In year three now. So this is the general pattern. Let we look to see if we could figure out if it have a common GP. So we're going to generate one more term. One more term we're going to generate. So let me generate one more term. So in January 2026, how much money she would have now?
$3,152.50.
Right? And in December 2026.
Um, $3,415.13.
Say that one more time. $3,415.13.
Yeah.
Okay. Let's see if we're noticing a pattern here. Let's see if we're seeing anything. Because you recognize that if it's an AP or a GP, that's good. We know what to do. We know how to keep going down the line, right? So let's check if it's a GP first. If it's a GP, what should it have?
A common ratio.
It should have a common ratio, right? So let's see. Tell me two consecutive terms to divide.
1,050 and 1,000.
Okay. Tell me what you get for that. Well, you get 1.05.
Yeah.
Nah, this wouldn't work out. This wouldn't work out. 2050 over 1050, that's like nearly a 2-time increase. So there's some discontinuity there. So if we work this out, it will not be a AP nor a GP. So there's something peculiar going on. So Annalie, if that's the case, then is it possible to look at the $1,000 separately?
Yes.
It would be. So they're saying that find the total investment at the end of 6 years, assuming each 1,000 gains compound interest from its start date. So they're saying that the 1,000 gains compound interest. So every year she's paying in $1,000, and so could we find the compound interest on that?
Yes.
Let me try to find the compound interest for that. Right? So that'll be equal to 1,000 by 1 minus, and that'll be 0.05. Actually, no, it wouldn't be minus 0.05. It would be plus. It would be plus. Why would it be plus?
Because it increasing.
It's increasing.
How come it's 0.05?
I converted 5% to a decimal.
Oh, okay.
And 5% as a decimal would be 0.05. Check that. Check
Yeah.
that. Okay. And we know that it's increasing, right? So then every year it should be 1.05. We established that. 1.05. And that'll be for how much years?
6.
6. So plug that into the calculator and let me know what you get.
$1,340.01. Or 10 cents.
$1,340 and
10 cents.
I don't see how that would help us much. So we know what the compound interest on the $1,000 is. Okay. And that still wouldn't apply to the logic of the question. That still wouldn't apply to the logic of the question. Because the $1,000 is going into the bank with the previous amount of money. And so it's not like a linear growth there. So let me try something else. Let me just continue down the line and see what happens. Let me do that and see what happens, right? And then try to form a pattern out of that. So in January 2027, how much money would be in the bank? So let me just keep on going. Fast. In January
Four-
2027.
$4,415.13.
Right, 2027. And you would need to find 1.05 of that.
$4,635.89.
$4,635.89.
Yeah.
Okay. Right. In 2028, that's gonna be 5635.89. And we gotta multiply that by 1.05. Let's see, I'm gonna get for that.
5,917.68.
Right? 5,917.68.
Yeah.
Okay. So that's in the 5th year. And we want to go to the end of the 6th year, the end of the 6th year. So in the 6th year, you'd add 1,000 to that, and that'll be what?
6,917.68.
And you'd multiply that by 1.05.
$7,263.56.
$7,263.
And 56. Yeah.
Okay, so that's the answer. Now, in the interest of time, I'm gonna leave it like this. And if I could speed it up and figure out a formula, I'll let you guys know. But that's just by looking at it is not an AP or a GP. And I have to verify the validity of the question. Because at the start, they are saying that she's investing 1,000 at the start of each year. Right? So if she invests in 1,000 at the start of each year, then and every year she puts in $1,000 into the bank. Amy, tell me if I'm losing my mind, right? But they're saying she invests in 1,000 at the start of each year. So end that mean every year she paying $1,000?
Yeah. Mm-hmm.
Yeah, that's what's going on. So every year she paying $1,000, and that grows at 5% annually. So in the first year, she would have put in $1,000, and that would have grown by 1.05. And so in the end of December 2024, it would have $1,050. And then if she invested $1,000 at the start of every year, she put back $1,000 to 2050, and that will grow by 1.05.
Yeah.
So that is why I'm thinking it logically sound and it makes sense, right? It makes sense. So Javon, this is a very weird question. I had to check the validity of it, but you understand the logical flow.
Yes, sir. Yeah.
Understand that every year she paying $1,000 and that growing by 1.05.
Yeah.
Okay, word. Is 2:00. I want to do two more questions, quick. I want to do two more questions, quick. So Javon, you'll get to see some calculus before you go. But I need to do these two tricky questions. It was these two cases that was really tricky. Right. So we're gonna do this question here. This is a tricky question. Amy, you remember this question?
Oh, yeah. Mm-hmm.
All right, this is a very tricky question. So I want to do this question with you all. Make sure you all know how to handle a question like this. All right. So Javon, I'll wait up more this question. So in this question, they want me to prove that sum to infinity is equal to xy by x squared minus y to the power minus 1. So Javon, in this question, are you seeing any values? Selma, just
No numerical values.
no numerical values. So we had a trust in the algebra. So we have a geometric series. So how would I find the common ratio? I would have to do what with the consecutive terms?
T2 minus T1, so y squared over x cubed minus y over x.
You said minus. This is a
Yeah.
geometric series. Check with it. The
Oh,
total size
but
of
divided by
divided by. So watch this, right? I'm gonna show you a hack here. They're gonna make your life easy. So we know that for a geometric series, you would divide the consecutive terms, right? So like you would take T2 divided by T1. You would say T3 divided by T2. Makes sense, right?
yeah.
That's what you would do. So this is T1, this is T2, and this is T3. So I would say T2 divided by T1. Does that make sense?
Yeah.
All right. So this is T2, and I'm going to divide that by T1. So I lose it anywhere, like you understand.
No, I get the
If I'm converting division to multiplication, what would I do?
multiply by the reciprocal.
Okay, see anything that could cancel off potentially?
Yeah, x into x cubed and then y into y squared.
All right, so we're gonna put what for the common ratio?
Y over x squared.
Okay, keep that in mind, right? Keep that in mind. And even if you could not see it, watch this. Check this, right? What would I have to multiply to get y squared? And y? Or would I
Yeah.
have to multiply by x to get x cubed? And x squared? Check
Yeah.
it. Y x squared. So it's making sense.
Mhm.
Now we need to find the sum to infinity. Kiera, remind me, what is the sum to infinity formula?
A over 1 minus R.
Right, so Kiera and Javon, I want to stay unmuted and help me with this question, right? So Kiera, what is the first term A? What is A?
Y over X.
Y over X. And that'll be 1 minus what, Javon? 1 minus
1 minus y over x squared.
right. Kiera, if we look at the denominator, does it have the same denominator? Are you seeing the same denominator over here?
Yeah.
Yeah, no. If I give you this example, 1 minus 1/5, do these two have the same denominator?
No.
I would need to find the LCM. So how would I find the LCM of this? This is like SCM maths. This is SCM maths. So I would have to find the LCM, right? So what would be the LCM between 1 and 5?
5.
Right? So 1 into 5 is
5.
right. So you know how to do that. So it's the same thing we have to do over here. I promise it's the same thing we have to do over here. And so Kira, since we're dealing with fractions and all kind of madness, this is what I'm gonna tell you to do. I'm gonna say, look at it like we have y over x divided by this whole thing over here. That's what I would advise you to look at it. And so Kiera, again, you recognize that we don't have the same common denominator, so we need to find the LCM. So we're gonna go aside and we're gonna find the LCM of that. So Kiera, what is the LCM between 1 and x squared?
X squared.
Right? So someone wants to put over here.
X squared.
Right? Minus
1.
nah. X squared into x squared is 1, right? And then 1 by y is 1y. So that's what we get the y over there.
Oh, I didn't really have to think about Y.
Yeah, watch this. If I have like a half plus a quarter, the denominator will be 4. So 2 into 4 is 2. And we're going to multiply the 2 by the 1.
Oh, we had the top. Okay. Yeah, I understand. Sorry.
Yeah. Watch again. This into this is 1. 1 by y is y. Right. So Javon, you understand everything so far, right?
Yes, sir.
Okay, so Javon, I'm gonna write it. I'm gonna plug what this is. So we found it. We found out it was equal to x squared minus y over x squared, right? And so you notice that it's a divide sign. So if it's a divide sign, I would need to change it to multiplication. So how would I change that to multiplication?
It'll be multiplied by x squared over x squared minus y.
You see anything that could cancel off?
The y and the x. Well,
No,
yeah.
you can't do that. Tell me why
Oh,
you can't do that.
what is that? One term.
Because it's more than one term. This is a binomial expression. Right now,
Yeah.
y involved with x squared. So you can't do that. What about the x squareds?
Yeah, I can do that. Cancel.
So one of the x's here would cancel off with one on top. So tell me, what would you be left with?
Um, y, wait, will be x equal to
Wait,
y
x is
multiplied by
equal to,
x squared.
wait, where you said x is equal to. How come you're saying x is equal to?
Cross multiply.
You can't cross multiply. You can only cross multiply when you have a fraction on either side. We're dealing with the right hand side here. So, Javon, I know it's looking complicated, but let me go back. Let me go back to standard 5. If I had a half multiplied by, let me just say like 4 over 3, how would I do that?
Find the LCM.
No, we
Oh
multiply.
no. Yeah, multiply.
So 2 into 2 is 1, and 2 into 4 is?
2.
And then you go say, what you go say
Um,
next?
2/3.
Right. So you go say this by this,
Oh,
and you say this by that.
well, y over x squared minus y.
Nah. Remember,
Or yx.
xy. So I'm gonna write it as, yeah, they want it as xy. So I'm gonna write xy.
Over x squared minus y.
Now let me look at the proof they want. It's xy by x squared minus y to the power minus 1. So okay. All right. So Javon, nth this over here is a whole term by itself.
Yeah.
If I take that whole term and I bring it up to the top, what would happen to the power? Amy, not Amy, Kira. If I take x squared minus y and I move it up to the top, what would the power become?
Um,
So check this out. If I had 1 over 5 and I take the 5 and I bring it up, that's equal to 5 to what power?
-1
Right. So if I take x squared minus y and I bring it up to the top, that'll become what?
minus
-1. It's the same thing. It's the exact same thing. It's the same thing. So anytime, because Kira, what's the understood power of this expression? 1, right? Are you seeing that 2 over here? Tell me, Kira, are you seeing any numbers over here?
no.
Nah. If you're not seeing any numbers, it's understood to be 1. So if I bring it up, it'll be -1.
Uh-huh.
Yeah. Javon, let me know if you understood how we got the answer.
Yes, sir.
Yeah, so this was one of the trickier ones, and this was a recent year, 2019. So you all should be able to handle questions that don't have any numbers in them. And you should be able to manipulate them by finding the LCM time to time and going from division to multiplication. Annalie, was this a question you'd be able to solve?
Hopefully.
Hopefully. Is there anything
Yeah.
that I'll lose you with?
No.
You sure?
Yeah.
Okay. And there was one question that was harder than this. Or there was also a question where you had to apply logs. I have a bunch of questions here, like a bunch of questions. All right, so let me look at 2023. I'm just gonna run through the hypotheticals, right? So Javon, if you're reading 2023, right? They're saying John's grandparents started a university fund for him at a bank with 4,000. The bank offered two options for interest, 240 per annum, and then 5% of the current balance. So tell me, Javon, the first option represents what?
That would be a AP and option 2 would be a GP.
Right. And alternatively, this would be what type of interest?
Simple.
Simple, and this could be,
Um,
number one, tell you, anytime you see percentage,
uh,
just compound.
yeah, compound.
Anytime you see percentage, compound. Right? So it's 220. I wonder if I could speak through them questions quickly, boy. And Javon, you say you had to leave 3 o'clock.
Yeah.
Okay.
I'll look back at the recording when I reach home though. So,
All right. So that being said, I want to make sure Ollie could be able to answer some past paper questions. So let me show you how to do this question. We're going to run through a couple past paper questions. So we're going to run through some hard ones before you go. All right. So, Kira, I want you to give this question a read. Javon, pay attention, right? Kira, I want you to give this question a read.
Alice deposited $4,000 into her new savings account at the Bank of Fortune, which pays an interest at 8% per annum. The bank's compounded interest is represented by the geometric progression.
Right. So, Kira, how much you put in at the start?
4,000.
So that would correspond to which unknown?
A.
You're real, I'm worried for you because in that maths exam in this year, you had to know that the initial amount was the principal value. Kira, if she deposit 4,000, and that's the amount of money she put in into the bank originally, yes or no?
Yeah.
Yes. And so 4,000 will be the principal value. Principal value, meaning that's the original amount of money she put in. So we have the principal value P. What else do we have?
We have the interest.
Right? So we have that. So that would correspond to which unknown? A, P, or R? Or T?
R.
Right? And what do you want me to figure out?
The number of years it takes.
Right, the number of years it would take. Number of years it would take, right? So at least what?
For the money to be at least triple.
Correct. So what is at least triple of 4,000?
12,000.
12,000. And that is, and what would we want 12,000 to be? That would be A, P, R, or T.
That would be A.
That would be E. All right, so let's plug in everything now. So that would be 12,000 equal to 4,000. How many rest, Kira? 1 plus
1 plus 8 over 100.
right? So what power? Do we know the time?
No.
No. Because if you read this question, what do they want us to find for? In that question, what do they want us to find for? Determine the what?
Number of years.
A number of years would be time, right?
Yeah.
So time is unknown. So that's the only thing we don't know. So before we do anything, let's look to simplify. So Kira, before we do anything, I think we can simplify inside the brackets. So where is 1 plus 8 over 100 as a decimal?
Um, 1.08.
Right? And is there anything I could divide by throughout that would help simplify? What is the greatest common factor? So what's a number that could go into both 12,000 and 4,000? The biggest number that could go into both of them?
4,000.
4,000. So I would divide throughout by 4,000 to simplify as much as possible. So Kira, what is 12,000 divided by 4,000?
That would be 3.
3. And 4,000 divided by 4,000 is?
1.
Right, so this could just be 1.08 to the power t. Because the 4,000 and the 4,000 would cancel off. Check it out. Right. See, now we'll cancel off. That might be cash out.
Yeah.
All right. Javon, I lose you anywhere?
No, sir.
Nah? Okay, good. Annalie, I lose you anywhere?
No, sir.
All right. Now, Kiara, I trying to find for t. T is at what? Look at where t is in the question. Where is t? T is at what?
A power.
If I trying to find for t, do I want it to be a power?
No.
No. So what? Did we do anything so far that would allow us to take a power and bring it to the side?
Yes.
Yes, we did. And what topic was that?
Logs.
Right. So entities have something called the power rule.
Yeah.
But for me to apply the power rule, I must have logs.
Mm-hmm.
So what do you think I should do on both sides?
But logs.
Apply logs. So I'm gonna apply log base 10 on both sides. So that'll be log base 10 3 is equal to log base 10 1.08 to the power t. Javon, if you was doing this exam, you'd have see that? You would have know you had to apply logs?
Honestly, no, but no. Why do I puncture in the 12,000, the whole thing, and 30, and use the skull function on the Casio? But I'm not sure if it's correct.
Yeah, you could do that. You could do that. But you wouldn't get the full marks though. But yeah,
Yeah.
I know what you're doing. I know what you're doing. Right? You're supposed to get the correct answer. Right? But Javon, and Annalie, you don't know what to do in this question. You don't know you have to apply logs.
I don't think so. But now I know, so that's all that matters.
Right. So I'm gonna make a copy down something. Anytime the unknown is a power, apply logs. Right. Because if you're trying to find for something, you need it to be linear. You need it to be to the side. So you need to apply logs. Right? And so Kiara, now that I have logs on both sides, what can I do with the t?
Make it the subject.
So before we can make any subject, which rule of logs you're gonna use? We want t to be to the side. We don't want t to be a power. So what rule for indices could I use? I have the quotient, product, and the power rule.
Probably the
So Kira, what do we want to do? We're trying to find for t. Do we want t to be a power?
no.
You want t to be like over here. So is there any rule that would allow me to take t and bring it down to the side? Check the formula sheets.
The product rule.
Products, no. Check page 3. Look for any theorem that allows you to take the power and move it to the side. So you would use the product. When you have a product of two things, we don't have that. We don't have any things multiplying by any.
Quotient.
The quotient, we use that when we have division. Are you seeing any division here? So which one remains?
Power.
So why didn't you say the power? Check out the rule fit. Notice that n, it was m to the power n, and after we apply it, what happened to the n?
It went
It went to the side.
yeah.
So just to confirm, I don't know if you're looking at this. Looking at this, right?
Yeah.
Okay, word. So we have to apply the power rule. And so doing that, we can take the t and bring it to the side. So that would be t log 1.08. So Kira, if I'm trying to find for t, what would I have to do on both sides? Right now, t is being multiplied by log 1.08. Okay, Kira, maybe if I swap it, maybe we'll just see it. So I'm gonna write 2 log 1.08 is equal to log 3. Imagine if I had x by 5 is equal to 20. How would I solve for that? How would I solve for x?
20 divided by 5.
Correct. You divide both sides by 5, right?
Yeah.
So what do you think we should do on both sides? What can I in the way of t?
1.08.
1.08 or log 1.08?
Log 1.08.
Right. You would have to divide both sides by log 1.08. Right. So it would cancel off. And so t would be equal to log 3 over log 1.08. And remember, LG means log base 10. So put log base 10 3 over log base 10 1.08 into your calculator, and you get your answer for t.
$14.27.
Right. So let me know if you understand that. So Amy, I think you remember me doing this question with you. Did you?
Yeah, I did it back recently too.
Say that again, Amy?
I did it back recently too. So,
Okay, word. So you good with this question?
yeah.
Yeah? Okay, word. Would. Javon, I have any point which I like severely lost you? Yeah, tell me.
Let's see. I have a question. Okay, if you put like 15 years, um,
That's correct. That's
okay,
correct. You can't say, you know why you can say 15 years?
because I know, I think that would be better for
You know,
this.
you know why they say that? You know why 15 is correct? Because it said to at least triple. So at least. What inequality sign is at least?
More than or equal to.
So in 15 years, it will be until we more than 12,000.
Yeah.
So that would satisfy the category there. At least triple. So 15 is correct. Annalie, let me know if you're okay with this question.
Yeah.
All right. By chance, Javon, when you worked in the Casio, did you get 14.27? Did it give you that?
Yeah, that's real crazy.
Yeah. I tell you, if you have a shop, like you real, you real cook boy. Yeah. Casio, they save lives out here. So I trust that everybody okay with this. Um, Amy, I can see who in the meeting. Is Aliyah in the meeting?
Yeah.
Okay. Aliyah, how are you?
Okay.
How chemistry?
It's good.
Oh God.
Yeah,
Yeah, don't talk about chemistry.
we don't.
Yeah, I feel like this better than chemistry.
At a point, yeah.
Ah, so we just now went through the question where you had to use compound interest and you had to apply logs to find the answer. I don't know if you remember this question.
Yeah. I was here a while, well, not a while, but a few minutes now. So I saw when you was doing it.
Okay, nice.
Yeah.
So Javon and Annalie and Aliyah and Amy and Kirsten and everybody here, I think it's just have some questions, ask me for questions, or they don't know how to answer. So let me go through. Um Kira, you think you'd be able to solve this question here?
Sir, I just logging in on my phone, right? Because I'm gonna be on the road. So
Okay,
yeah.
that's no problem. Kira, you think you'd be able to solve question C?
Yeah, probably.
Probably. Let me read the question quickly and I want you to explain it to me. So read the question for me quickly.
Harrison University graduate was offered a starting salary of 720,000 for the first year with increases of 5,000 at the start of every year thereafter. Determine the number of years to the nearest whole number that it would take for her annual salary to be 20% greater than her salary in the first year.
All right, so let me work this question out quickly. So I'm gonna speed through the whole question, right? We went through all of the rules for APs and GPs, so I'm trusting that you're okay. I'm going to be moving fast now. Rapid attack. All right. So Kiara, let me go. Rail speed. Part B. What part B looking like? In part B, what are looking like? AP or GP?
GP,
I'm looking like a GP. How would I prove that as a GP?
um,
All GPs have a what?
a ratio,
A what ratio?
common ratio,
Right. I want you to make a note of that now. All GPs have a common ratio. Right, I feel like the cat distracting you, you know. I feel like the cat. I want to tell your mom to take care of the cat. Right? And Kiara, we call her R. And do you remember the formula for R?
Yeah, Tn plus 1 over Tn.
Right. So tell me fast. Pick two terms, and then we find the common ratio. So pick two terms.
5 minus 20. 5 divided by 25.
Nope, that's not true. This is -5.
Oh,
Be very careful of that. So -5 divided by 25 is
mm, minus 1/5.
okay. Tell me a pair of two other terms.
Minus 1/5 divided by 1.
What are we equal to?
Minus 1/5.
Right? Let me try another one just to be safe. Aliyah, tell me, give me a pair of consecutive terms that I didn't use as yet to divide.
Um, hmm,
So
like
like I use -5 and 25 already. I use
okay,
I check -1/5 and 1. So
you could use 1 over 25 and 5 over 5 or 1.
no, it has to be consecutive. So if you're using 1 over 25, you
You
have
could
to
use
use this.
1. Okay,
So like what? You notice what? Look at this, right? -5 and then -5 and then divided by 25. So it's
yeah,
always the next term divided by the term that was before it.
before. Okay,
So if you're using 1 over 25, then you
you
have
have
to,
to use minus 1/5.
right? So plug that into the calculator and let me know what you get. Right?
I
So
get minus 1 over 125.
nah, supposed to get a -1/5. So
Yeah, yeah.
make sure you get it in the Casio.
Um,
So in the Casio, you're gonna when you press the fraction button and a fraction come up, you had to press the fraction button again, and
yeah.
then this will come up. And then you put the 125, and then you press shift to the right, and it will end up over here. And then you would have to press the fraction button again. Then you put the -1/5. So make sure you
I
get
get
it
minus 1/5. Yeah.
okay, would -1/5. And so Aliyah, does it have is the ratio common, meaning that is the ratio the same for all terms?
Yeah.
Right. So since, or is this a series or a sequence?
Um, a series.
Yeah, they tell you that. They tell a
Yeah.
series. So since the series has a common ratio, since the series, okay, cool. Kira, help me with part two. So Kira, what are you asking us in part two?
To calculate the sum to infinity of the series given the answer to two decimal places.
Right, tell me the sum of the infinity one time.
A over 1 minus r.
Wait, where's a over 1 minus r?
It would be 25 over 1 minus 1/5.
Correct.
Mm, I get 25.2.
You get 25.2,
Yeah,
like exactly.
yeah.
So you just put 0.20 because it's two decimal places. So just put 0.20, right? So you have two decimal places. Right? So somebody just verify that. Just verify that. Annalie, verify that from a class. Wait, Kira. Kira, you got 25.20.
I gained 20.83.
I gained 20.83 as well. Kira, run that back. Run that back.
I forgot to put my brackets.
Oh my God. Be careful. Kira, I feel like I had to come by you and make sure you do not advance, you know. Either that or go had a game on to take rid of the cat. Feel like it's the cat fault. Kira, what do you think? You think it's the cat's fault? Kira is remaining quiet. Kira, are you getting 20.83?
Yeah,
Yeah, Kira, do you think it's the cat?
no,
It's Eden.
no.
I feel so. So we get the answer for 1 and 2. Nice. Part C now. So Kira, let me do part C. So in part C, a recent university graduate was offered a starting salary of 720,000. So Kira, if the starting salary is 720,000, would that be the first term?
No.
Yes. Because they start off with that salary. And A is the what? Remind me, what is A?
The first one.
Right. So the person starts off with that amount of money. So A would be 720,000. I want you to continue reading and see if you have any other pieces of information. So with increases of
I can't see. With increases of 5,000 at the start of every year thereafter.
wait,
Determine
is this a AP or a GP?
your GP
What make you say a GP?
because it has a common ratio, so it's
Common ratio? No. This question and this question are separate. So here, I hear what they're saying. They're saying with increases of 5,000 at the start of every year. So what does that mean? Every year the person's salary gonna
increase
buy.
5,000.
So let me just say in the first year he make $1,000. How much money he gonna make in the next year?
2,000. Oh, 6,000.
Next year? Does that look
11,000.
like a AP or a GP?
At AP.
Yes. So anytime they give you a fixed value and they are telling you that it increases by that fixed value, it's a AP. So keep that in mind. So anytime you see increases by a given amount of money, and that's AP. Automatically, that's a AP. Yeah, hope you understand that. So determine the number of years, the nearest whole number that it would take for her annual salary to be 20% greater than her salary in the first year. So Kira, what is the salary in the first year?
720,000.
And they want us to figure out how long it would take salary to be 20% greater. So first of all, we need to figure out how much that new amount would be. So what would 20% greater than 720,000 be?
It will be
Should be 840,000 or something like that. I don't know. Nah. Let me check it.
I think I do it wrong.
Just be 864,000. So let me show you a hack, right? So Kira, if the salary is increasing, if you want to figure out how long it takes to increase by 20%, what is the salary going to be? If 100% is the original amount and it's increasing by 20%, what is the new percentage going to be?
80%.
The 120%. Yeah, here what's in again. So we want to figure out how much years it will take for it to be 20% greater. If you see greater, do you think you should add or subtract?
Add.
Add. So 100% would be the original amount of money, and then 20% would be the increase. So 120%. What is 120% of a decimal?
120 over 1.
If you want to convert a percentage to a decimal, you divide the percentage by 100. So 120 divided by 100 is 1 point.
6/5.
Say that again?
6/5.
So that is 1.2, right?
Yeah.
So a simple trick all you could do is, like, if I wanted to figure out the total amount, I would say 720,000. I would take that and I would multiply by 1.2, and you would immediately get your answer. Annalie, you know how to do that?
Yes, sir.
So Annalie, would you have had find 20% initially and then add it on? Or you could just like do this and get your answer one time?
This one.
Okay. All right, Aliyah, tell me if you're confused by the 1.2. Aliyah,
Yeah.
you confused by the 1.2?
And that's the percentage. Is that the percentage?
So that's a decimal.
Right.
So Aliyah, they want us to figure out how long it would take for her annual salary to be 20% greater than her salary in the first year. So in the first year, her salary is 720,000, right?
Yeah.
And so what you could do is you could find 20% of 720,000 and then add it to 720,000. You would do that,
Yeah.
right? That makes
Yeah, I
sense.
would. Yeah.
Another way to do it is 20% greater than her starting salary. Her starting salary, we could look at it like if it was 100%. So now we want to figure out how long it will take for the amount of money to be 120% of the starting amount, which is 1.2 as a decimal. So 1.2 by 720,000, that is our answer, rather
Yeah.
than having to find it separately and then add.
And then adding it. Yeah. Okay.
You just say 1.2 by that.
Yeah.
If they say it increased by 50%, I would just say 1.5 by 720,000.
Yeah.
Right. Cool. So Kira, now that we know the amount of money we go in for, we need to figure out how long it's going to take. So Kira, do you know how you would proceed next? Okay, tell them I get like some space over here. I get some space. So Kira, and we know is that what, a GP or AP?
AP.
We know is a AP. We know it's our AP. So I want you to look in the formula sheet to see all the formulas it have for our AP. And so Kira, we know what A is. We know the total amount we want to get. But not really the total amount. We know that we want to get a salary of 864,000. So like take for instance, right? Kira, in the first year, how much the person will be making? In the first year.
720,000.
In the second year, how much?
That added to 725,000.
Right. And you would keep doing that, keep doing that, keep doing that until we get 20% greater than 720,000, which is 864,000. So Kira, in the way I just now explained it sounds like we're trying to figure out what so again 720,000, 725, 730, and they're going all the way down to 864. So it comes like we're trying to figure out the what term. The formula look like we might have to use.
Um,
So you have two formulas. You have T of n and you have S of n for APs. Which formula I think we have to use? And we know that the common difference is 5,000 because that's how much money she gain every year after. Like that's the increase.
it will be the TN one.
Right. Because here how I explain it, right? 725, then 730, and 735, and 740, all the way until they reach 800. So that comes like we're trying to figure out the term, right? Trying to figure out the term. All right. So, Aliyah, would you have been able to figure out I have to use the T of n formula?
No,
No?
I wouldn't have figured it out had I do it the long way.
The long way?
Like,
Good
you know
luck.
now.
And I know what I mean, like I say 725, then 730, then 735, then 740, then 745, then 750, then
Yeah.
oh my God. Annalie, would you have done that as well?
Probably.
Oh my. Well, it's scared me, you know. But Annalie, you understand where I'm coming from, right? It come like we trying to go up to that term. And that term we
Yeah.
trying to go up to is 864,000. So we would use the nth term. Amy, would you have had to do the long way or would you have seen that could I use T of n?
I think I would have seen
I know why, you know, because you have glasses,
all that.
all that. Aliyah, you don't wear, no, Aliyah, you just wear glasses, and
Yeah.
so you should have seen it too. Annalie, you just wear glasses,
No.
then it's okay if you don't see it. You don't have glasses. Rest of them are supposed to see it. So it come like we're trying to go up to this term. So we have to use the T of n formula. So remind me, what is the T of n formula? What is the T of n formula? Somebody remind me, anybody?
T of n is equal to a plus in brackets n minus 1b.
Right. And Kira, remind me, it come like we're trying to go up to what term? The term with what value? So remember how it will go. It'll be 720, it'll be 725, it'll be 730, it'll be like 735. And we want to go all the way up to the term with what value?
864,000.
Right. So then whatever this term is, it will have what value? It will have this value, right? So Kira, is it that so do we know the value? We know the value of the term, right? The value of the term is 864,000. But Kira, do I know what the term is? Do I know if it's like the sixth term, the eighth term? Do I know?
No.
So that is why I need to use the T of N formula, because I don't know what the term is. Finally, you see, now I don't know what the term is. I simply don't. I know the value of the term, but I don't know what term that is. I don't know if it's the ninth term, the 10th term. So I use the nth term formula. You can see it now?
Yeah.
Yeah. Aliyah. Aliyah, I feel like what's saying common, either one is I'm going through the other. I feel like you're just saying, I'll do the long way, I'll do the long way. I'll do the long
No,
way.
I get it now.
Okay. So I'll put down the working so that everybody will see it, right? So 720, then 725, then 730, 735, all the way to like 864. Just a second. All right, so that is why we use the T of N formula. So, Kiara, what is the value for this term that we don't know? So the term that we don't know, what's the value for it?
I don't know.
You do know,
All the values, the 864,000.
right? So I'm gonna put that equal to the term. Again, we don't know what the term is, so we're trying to find what term it was. That'll be 864,000, and that'll be equal to what? Tell me, Kiara, what's the first term?
Um, 720,000.
Right? Do we know what n is? Do we know what the number of the term is?
Yeah.
You sure about that?
No.
No, Kira, a way to understand what happened in it. This is the first term, this is the second term, this is the third term. Do we know what term this is that would give us 864?
No.
No, so we had to leave that as a blank. That's gonna be n. Right? So n minus 1. And what is the common difference?
5,000.
Right. So now we just have to do algebra. So Kira, I could take the 720,000 and move it across to the other side if I wanted. And so that would be 864,000 minus 720,000. So what would that be, Kira? What is 864,000 minus 2? Think real loud. Kira, have,
What?
see have real noise by you. And remember, I have like real speakers, so I hearing the truck passing and thing.
Oh.
So yeah, Kira, what is 864,000 minus 720,000?
Um, 14,000. 145,000.
Right? And that will be equal to n minus 1 by 5,000. But you think we could leave it like this?
No.
Yeah or no?
No.
What do you think we should do?
Um,
So Kira, we have n minus 1 by 5,000. Anytime you have something in by brackets, what do you feel you should do?
multiply.
Right, I should probably expand. So that'll be 144,000. And And that'll be equal to what? So we have n minus 1 by 5,000. So this 5,000 on the outside would multiply by all of the terms on the inside. So 5,000 by n is,
5,000
right? And tell me what the other term would be.
5,000.
Minus 5,000, right? And maybe this might be looking confusing. So what you guys could do is you could swap the order. And so I could write 5,000 n minus 5,000, and you would see that that's equal to 144,000. And so Kira, what would I do next if I want to find for n?
Divide, so it would be
Now, I would have to do what would be minus 5,000.
critical.
Yeah. If I carry across the minus 5,000, it's gonna do what would be 144,000.
Add
Correct. And so that's gonna be equal to 1, 4, 4, no, 149,000. Aliyah, just confirm that much real quick. Right? And
Yes.
so, nice. And so, Kira, if I want to find for n, what would I do on both sides?
divide by 5,000.
Correct, I would divide by 5,000. So n would be equal to 149,000 all over 5,000.
2.8. 28.8.
28.8. So Aliyah, and for everybody who would do the long way, Aliyah would have to keep on going 28 times.
That's what I
Aliyah,
was.
28 times. So you would have had to say 720, 725, 730, 735, 740, 745, 750, 755, 28 plus 9. That do make sense.
It does. Yes.
So, Kira, 28.8, if I round it off to the nearest year, what that would be?
99.
Right. Yes. Kira, I feel like your mood kind of, you're not there. You sound like you're tired and you're frustrated. Would that be right? Like you're sounding, sounding like yourself. Are you okay?
Yeah.
You need a break? A little break?
It's okay.
All right. So, Annalie, you know what to do with that question like this now?
Yes,
Yeah, so Annalie, you don't have to, you don't have to add 5,029 times. Yeah, that's crazy. That'll take up real time. So anytime you're trying to go up to a term and you're not sure what the term is, but you know the value of the term, you have to use the T of N formula. And the algebra is the hardest part here. The algebra. Now, for some of you all you would have probably noticed that there's another method you could do over here. Amy, you see that you could also divide by 5,000? Amy,
Yeah.
yeah, so like, I'm going to show you another method. So when you reach this point, another thing you could do is, say that I have 144,000, and that will be equal to n minus 1 by 5,000. And so, Aliyah, if I divide both sides by 5,000, right? Let me see what can happen. So, Aliyah, check this out. The 5,000 will cancel off with this. And so tell me what you write in the next line.
N minus 1 is equal to 144 over 5.
And what is the answer decimal by chance?
28.8
And all we would have to do is
minus 1. No, plus 1, sorry.
plus one
I
on
said
both
plus
sides.
and plus 1. Yeah.
So what would they rather do? Would they rather do that, this, or all this?
No, the second one.
Yeah, the second one is definitely the method to do.
Yeah.
But wait again, 29.8. You sure? Let me check something. Let me check that real
And
quick.
yeah, just hold on. Yeah,
Wait, so we're supposed to get something
29.
right. Something not right. Let me just check back that. Yeah, when I work this out, are they supposed to get 29.8? Yeah, not 28.8. Yeah, they're supposed to be 29.8 here. Answer that'll be 30 years. Yeah, annually. You see how simple it is, like if you do this method,
Yes, sir.
like it's crazy, right? Like you just skip so much lines are working. So this is it. I would prefer if you all did this. Amy, I guess, and you do that. Amy, what did you do? Method one or method two?
The second one.
Okay, word. Word. All right, Aliyah, I guess then you're gonna do the second method now. Nice. Rather than having to expand. Okay, Aliyah, since you didn't get to help me with that question, let me just do so I want to do 2023 and 2024, and then we're gonna move on to calculus. I'll give all like a 10 minutes break, and we're gonna move on to calculus. Oh, Annalie, are you doing chemistry as well?
Yes, sir.
How are going for you?
Mm,
Everybody finding this chemistry thing real. I am yet to hear a person say they like chemistry. I'm yet to hear a person say they like chemistry. So Annalie, you don't like chemistry.
no.
Exactly, that's the question. Who likes chemistry? People who like to hurt themselves like chemistry.
Sometimes chemistry just be fun though. Like electrolysis is a very easy topic.
Well, you will help Javon with that. Javon, you there?
What? No, uh, no, he not in class.
Oh, yeah, he said he had to go. Yeah, he at the start of class, he tell me, nah, electrolysis stuff.
No, it's not. Like once you understand, like once you understand what you're doing, it could be easy.
Yeah. Glad I don't have to worry about that. I'm so happy. I don't have to worry
Yeah.
about that. I would pick maths over chemistry. Maths is the only reason I pass chemistry, chat. Maths is the only reason I pass chemistry. I tell you that. I rarely do maths in chemistry in my chemistry exams and I pass. All right, so Aliyah, help me with question 2023, right? And Annalie, you help me with 2024. Amy, um, you just relax. No, don't relax. Ascend section 3. I would like you to attempt the questions in that, right?
Yeah, I reached number 9.
Number 9, Whitney Jail.
Well, I kind of halfway finished it and I'm taking a break.
Amy, you dread boy. You real dread. What the hell? And you don't do art maths in school, eh? Amy, they just do art maths with me privately. That's Amy, you just go to it, boy. You just Annalie, if you don't know any better, ain't you look at Amy and see she's a science student?
Yes, I thought she was gonna do sciences before.
That
And
why,
then I see she in 5B.
like, what you doing in the business class? You don't have no business being in the business class. But then again, you're probably real good in business. I don't know. Actually, yeah, you sell plants and things, so you're probably good in business too, right? So, Aliyah, let me mash up 2023. You know, you and John is very good friends. Yeah, he's bully you. If Jonathan would come to this, he go real. Is that good thing he not here? Yes?
For real.
All right, so Aliyah, John's grandparents started a university fund for him at a bank with $4,000. The bank offered two options for interest. Option one, 240 per annum and 5% of the current balance. Determine the sum of money in the university fund at the beginning of the ninth year for both options. So, have two ways you could look at this, right? Option one is, so Aliyah, how would you do this? Option one looking like what? What is option one looking like?
Um,
So, 240 per annum. What does that mean? 240 per annum.
that's like 240 per
So every year it's gonna increase by,
240.
and so what that sounding like a AP or a GP?
Um, sorry, my throat dry.
That's okay, I understand. So if you add in something every year, what that sound like a AP or a GP?
Uh, that's like AP.
Yeah, that's a AP. Arithmetic.
Yeah.
Add, right? I'm waiting. Option two sounds like automatically. If
A
option one was
GP.
a AP, then option two is a GP, right?
GP. Yeah.
Now let me show you another way you could look at it. This is the easiest way you could look at it. Option one is simple interest.
Mm-hmm.
I think everybody know the simple interest formula by now. And so this had a learn simple interest in Standard 5.
Yeah.
Yeah. I forget why I learned in Standard 5.
I
And
think so. Yeah. We had to learn the formula.
I think so, yeah, yeah. P by R by I
Oh,
o- over 100.
yeah.
Yeah. And it had T in that as well. Principal by rate, no, it's principal by rate by time. P by R by T over
P
100.
by R by T over 100.
And,
Yeah.
and option one is simple interest. So what do you think option two is?
Yeah.
5% of the current balance.
So that's
So that means
it's
every year
they
you're gonna
deduct.
find 5% and add it.
Okay.
And the next
5%
year,
of the
yeah,
balance.
yeah.
And yeah.
So that's compound interest.
Mm-hmm.
So we have simple interest and compound interest. Annually, would you see it like this? Compound interest and simple interest?
Yeah.
Okay, would. You probably would have ignored APs and GPs. You'd be like, what is that? I was sure how to do both. Right? So simple interest. Annually, you tell me the formula for simple interest, right? What's the formula for simple interest?
Principal by rate by time all over 100.
Right. And Aliyah, what's the formula for compound interest? You're supposed to know you get it for maths this year.
Does A is equal to P by 1 plus R over N to the power.
Chat, just confirm that is the formula for compound interest. Aliyah, and she did tell me the math exam wasn't bad.
Yeah, it wasn't bad.
That was like so much easier than 2025 Jan.
That's January. Yeah, that's what I'm
Like, oh
saying.
my God. That actually looked like a math paper. It actually looked like a math paper. Right? So
Yeah.
just confirm that both of those formulas are correct.
It's to the power T.
TN?
It don't matter.
Yeah.
It don't matter. NT, same thing.
Yeah.
Yeah, it don't matter. You understand why, right? Because N is the number of years, T is the number of years. No matter, right? But for the sake of being correct, I'll put T. But it doesn't matter. Right. So, Annalie, let me do the first option. So in the first option, what is the principal?
4,000.
What is the rate?
Mm,
Ah,
240.
no, rate is a percentage. So you want to show you how to find your rate?
Yeah.
So to find your rate, it will be 240 over what? You make a guess.
100. 4,000.
4,000. Multiply by 100. No, that's a percentage. Well, yeah. When you're using the simple interest formula, rate had to be in a percentage. You understand what I mean, right? Because it's R over 100.
Yeah.
Yeah, so what you get for this?
6.
Right, so the rate is 6% over here. And the time,
9 years.
right, and that'll be over 100. Right. So 6% is 54. 54 by 4 is 216. So is the answer 2,116? No,
Ooh,
no,
close.
2,116.
Yeah.
Avara, Avara. Some of them are impressive. I'm like, oh my God. Maybe I feel myself too much. Let me stay humble because next question I might try something and I might do it wrong. Like what happened with the other time. Right? So 2,160, right? Oh,
Yeah.
okay, word. And Aliyah, let me do compound interest now. So Aliyah, you need to understand something. In the compound interest formula, when you find for A isn't the interest, is the what amount?
There's your balance.
I don't do business.
I mean it.
That is, that is the accumulated amount.
Okay.
That's like the total amount of money after the years. So if you wanted to figure out the interest, you would need to
To do compound interest.
wait, hear that one more time. When you use the compound interest formula, you're finding for the accumulated amount. So the
That's
total amount
the
of money, including
okay.
the interest. So if I wanted to find for the interest alone, what would I have to do?
Simple interest.
No. If
Um,
if I find,
I
let me just say I get 5,600.
right.
How
So you
about that?
minus it
Minus that from what?
from the compound interest.
No, this is the compound interest.
Oh, so you minus that from what you had at base.
Yeah, exactly.
Okay.
That's exactly what I had to do. Because remember, when you put money in a bank, you get interest on it. And so there's a certain amount of money you add in to the investment.
Yeah.
Right? So what is the principal value?
4,000.
And what is the rate they give you for option 2?
5%.
5. So that'll be 5 over 100 to the power 9. And tell me what you get for that.
Um,
Alia, you think I could do that in my head?
you go ahead and try.
I'm thinking 6,205
Uh-huh.
0.32.
0.31. But you get through. Very close,
It was
very
close.
close.
I keep
Don't
doing
be
this thing where like I go in real close, but
That's fine. You get a big number.
right, 6,205.31.
0.31. Yeah.
All right. And that is the total amount of money, yeah? That's the total amount of money that was accumulated. So if I
Okay.
wanted to actually find the interest, how would I find the interest?
You minus it from your 4,000.
Yeah. And what again?
Um,
Suppose I get a
so yeah,
right? And so which is the better option? Which is the better option? Simple interest or compound interest? Which one had the most interest?
compound interest.
Right. Annalie, I feel like you'd have want to use simple interest, but you would have probably be like, what is the rate? What is the rate? You'd be wondering that sense.
Yeah.
Yeah. So this is how you find your rate. So the rate is just the fraction of the original amount of money. So like, think about it. That makes sense because if you're getting 240 per annum, that is equal to 6% of 4,000. So you good, right?
Yeah.
Right? And Aliyah, you was telling me the compound interest is the better option, right?
Yeah.
Yeah, so this is the better option. So the interest for, say, answer for both of them, the interest could either be 2,160 or 2,205. I feel like everybody understand this method, so I don't think I need to do the AP and GP approach. Are you okay with this, right? Like no confusion.
Yeah.
I don't think I want to do anything else that can possibly confuse all you. In the exam, just make sure you remember simple interest and compound interest. How do you know if it's simple interest? Well, simple interest is a fixed amount of money, right? It don't change. So, Aliyah, in option one, you see you're getting 240 per annum.
In option one?
Yeah, option one, 240 per annum.
Yeah.
So watch this, right? Annalie and Aliyah, watch this. And Kiera, I didn't forget you, Kiera. I didn't forget you. And Kirsten, I didn't forget you. Right, watch this. NT effectively, if only look at this part. Aliyah, to get these 6%, what to do? To get these 6%, what to do?
You find 240 of the 4,000
Exactly.
and
That's what I do, right?
240.
So 6% is just 240. We know that. And that's what we're doing over here. Watch,
Yeah.
6 over 100.
Yeah.
We finding 6%. We finding 6% of 4,000, right? And we multiply that by 9. Right. So everybody okay with this question?
Yeah.
All right. Let's move on to 2024. And then after this, I'll give all a 10 minutes break. And we come back and we go do calculus. It isn't that long, and I definitely gave you all some tricky questions. So it should cover the whole syllabus. Right? Annalie, I didn't get any questions from you. You try any questions after yesterday?
Yes, sis. I wasn't sure if to actually send them because anything I had problem with, I look up the solution online.
Okay, and you got through, right?
Yeah.
Okay, well, if you ever feel like you don't understand it at all, feel free to message me. And all you had to get at least like a 2. Amy. Hey, not at least a 2, eh? I wonder if Amy saw that. But I wanted to take at least a 2. So Aliyah, have you been practicing any questions?
For add maths, not yet. I start,
What?
yeah, no, I mean like I do questions, but like it wasn't like from what you sent. It was from the booklet.
Okay.
And I went to a crash course over
Mm-hmm.
the weekend.
Right.
So I was doing questions from that as well.
Okay, okay, word, word.
Yeah.
All right. So let me keep pushing. So, who are they call upon to help me with this question?
Me.
You? Okay, so let me go, right? So you should know by now that that's where you're starting at. This is how you would get your general term, and this is what you're going up to. Remember?
Yeah.
So let me start. So your first term would be 5 to the power,
0 minus 2.
right? Plus 5 to the power,
1 minus 2.
plus 5 to the power,
2 minus 2. 3 minus 2 and 4 minus 2.
right? 5 to the power minus 2. Like, guys, or like you just plug that into like calculator, to be honest. But 5 to the power minus 2, that should be 1 over
1.
25.
Yeah.
Because from indices, 5 to the power minus 2 means 1 over 5 squared. Since the power is negative in the numerator, it'll go to the denominator, so it'll be positive. So 1 over 5 squared. Right? The other one will be 1 over 5, because 5 to the power minus 1 will be 1 over 5. Then 5 to the power 2 minus 2 is 0. 5 to the power 0 is 1. Then they will have 5, and then 25. And say answer will be, let me see if I can calculate this in my head. 31, and so that'll be 31 and 126 over 25. So I feel that'll be 31 and 126 over 25. I'm gonna check. What is 126 over 25? So the answer will be like 32, 125 or something. What the answer gonna be?
781 over 25.
Okay, you had to give your answer as either a decimal or a mixed number.
Oh.
Mhm.
31.24.
Okay. Again now, it's closer. 31.24, right?
Yeah.
Okay, so that's the answer. And all in all, I could plug this into like Casio, right? Did you all know that? Yes or no?
Yeah.
Yeah.
Okay, so I want somebody to plug it into your Casio and send me a picture on the chat for proof. That know how to do it. So plug that into the calculator, send me a picture, and we'll move on. Right, so Aliyah, I want to see you plug that into your Casio. Okay, Annalie, that's not what I mean, you know. That's not what I mean. Let me get my Casio and show you what I was talking about. Am I blowing your mind?
I'm not getting the option to like, you know how is um different values you're minusing the two from.
Wait, say that again?
Like the x. Okay, so on the let me show you what's open on it
All right, let me get my Casio.
because it's
Coming back. I'm gonna get my Casio.
okay.
All right. I'm not sure what I'm talking about. Ali, I sent it on the chat.
I sent it to you.
Oh, okay, I'm gonna show you how to get the X. Don't worry.
Okay.
It looked like
I
you
mean,
it
the
looked like
x
you
over there, no.
it looked like you forget the X. That's good, that's good. That's good. Right? All right. So let me show it real quick. So you're gonna press shift and the log button. Oh, I can't see it like that. Oh, right. So Annalie, I'm not sure if it's the same for your Casio, but you should see a yellow Sigma button. Right? Since you get that, you're gonna press shift, and in my case, I have to press log base, right? And then I'm gonna input the expression. I'll send the video. So you're gonna put 5 to the power. I have I, so I'm gonna replace I with X. So to get X, I'm gonna press alpha, close bracket, minus 2, right? In the bottom, I'm going to put 0. And on the top, I'm going to put 4. Yeah, so that is what I was talking about. Check that, check what I just sent. Aliyah, you get my sick.
How I get you sick?
I don't know. I feel sick. I feel sick. All right, so that's what I was talking about. Actually, did you know that you could plug in Sigma on the calculator?
No, sir.
You have a Casio. You know your Casio could solve equations for you, right? Your Casio could solve equations. You could literally put in any equation on the Casio will solve it. Right? So Aliyah, to get the X, you had to press alpha, close bracket.
Yeah, I get you. So the x could be equal to 0.
Yeah, X could be equal to 0 because they say I is equal to 0.
Yeah. Okay.
Right? So Annalie, let me know if you get through.
I got you.
Yes, sir.
Okay, nice. Glad to hear everybody get through. Kiera, I know you're feeling a little under the weather, but try it. Plug it in the calculator and let me know if you get into 1.24. All right? So let me keep pushing. So E, determine whether the following sequence is divergent or convergent. Justify your response. So Aliyah, does the fractions look like they're getting smaller and smaller? So we start off with 1, and we have minus 8 over 27.
Yeah.
Yeah. So question, is it looking divergent or convergent?
Um,
So a convergent series is a series that converges to a point. In other words, the terms get smaller and smaller and smaller and smaller, so that eventually it's so small that when you add it, it wouldn't make a difference. So it converges to a point. So are you noticing that it's getting smaller and smaller and smaller?
yeah.
Right, so it's convergent, but we need to prove that. So to prove that a series is convergent, well, this is a sequence because you don't have plus sign in the middle. To prove that a sequence is convergent, you need to find the common ratio and prove that the common ratio is less than 1. So there we go. So Leah, tell me how we're gonna find the common ratio here. Leah, how am I gonna find the common ratio? Remind me, how do you find the common ratio for GP? Because that's a GP.
That is you're finding the difference between the values.
No, no. I want somebody to explain. What do you do for anytime you have a GP? What do you do to find the common ratio?
Tn minus 1 all over Tn.
Right. That's it. Or you could say Tn plus 1 over Tn. So, Aliyah, anytime you have a GP, you divide successive terms. So I will divide the second term by the first term, the third term by the second term, the fourth term by the third term. That's what you would do. So what's the second term?
Minus 2/3.
And where's the first term?
1
Where's minus 2/3 divided by 1?
minus 2/3.
Right. Cool. Next up, R would be equal to, give mom another example.
Minus 8 over 27.
Minus 8 over 27 divided by 1.
4 over 9.
Plug that into the calculator and let me know what you get.
I get minus 2/3.
All right, so you got minus 2/3. Cool. So what does that mean? So what does that mean about the common ratio?
It's minus 2/3.
Okay, and is that less than 1?
Yes.
Right. Since R is less than 1, the series will converge. If you had a series for this where it was adding, it would converge. So Aliyah, anytime they ask you to prove that a sequence is divergent or convergent, you have to find the common ratio. Aliyah, the only time something diverges or converges, well, the only time they would ever ask this kind of question is for a GP, because a GP is the only kind of sequence that could converge. Arithmetic progression can't. So anytime you see this kind of question, just know they're talking about a GP. And for a GP, you have to prove that the common ratio is less than 1,
Okay.
right? So I'm going to give everybody a 10-minute break, and we're going to start back with calculus. Yeah. All right, guys, I'm gonna follow you there. Aliyah, are you back? Annalie, are you there? Amy?
Yes, sir.
Yeah. Oh, I now realize, watch this, right? 3 people here have the name starting with A, and 2 people have a name starting with K. That's crazy. Like, it only now hit me that nearly everybody here name A. So names are with A. But yeah. So Annalie, you back? Amy, you there? Aliyah, Kirsten, Kira. Oh, Annalie, I realized there was an error in that question. So the question ended here with simple interest and compound interest. Can you spot it? We didn't do any maths wrong. It was just something that they said. Something that they said. They said something.
The sum.
Nah. Oh yeah, that too. That too. We're supposed to incorporate, we're supposed to find the sum. Uh that's something, but a way to check something out here. They're saying to determine the sum of money in the university fund at the beginning of the ninth year. So if we're talking about the beginning of the ninth year, do you think it get the interest at the beginning of the ninth year or the end of the ninth year?
The end.
Yeah, so that was the trick. So we're really supposed to use what for n?
8.
Supposed to use 8. This is such a sneaky little trick. So sneaky. Because in the previous questions we did, right? Let me look at the previous question. Watch this. At the start of the year, and you would have the original amount of money, and it's only at the end of the year you would get a change.
Yeah.
Yeah. So we have to pay a little more attention to what the question is saying. So let's correct the errors. So we'll replace 9 with 8. And so if that's the case, tell me what you will get there. So 4,000 by 6 by 8 over 100.
$1,920.
Right. Exactly 1,920.
Yeah.
Okay, cool. And over here, like, it's supposed to be 8. Supposed to be 8. Yeah, tell me what she gets.
$5,909.82.
Tell me that one more time. Run that back.
$5,909.82.
That's what you just want to say?
Yeah.
Okay. I feel like, by the way, sorry, if like my voice on weird or whatever the case is, I kind of sick and my nose running and things, so I saw a little congested, right? I saw any difference or I saw normal.
It's on normal.
Okay, cool. So, Annalie, and that was one thing. And another thing we're supposed to pay attention to is the fact that it's saying some. Some. So, is this already in the sum?
No?
Yeah. Remember, when you do compound interest, you're finding the accumulated amounts. So that's the total amount of money. Think of it like this, right? Annually. And when you invest money in a bank, well, I don't think you ever invest money in a bank. But if you do invest money in a bank, you put on the original amount, and after X amount of years, you would get some money on top of that. And so that's the interest. So look for instance here. by putting in 4,000 into the bank for 8 years, how much money did I get?
$1,920.
So what's the sum of money I'm gonna get? Remember, I did put in 4,000, so what's the amount of money I get in total?
4,000 plus the 1,920.
Yeah. And you're supposed to get 5,920. All right, so this is the sum. Right, and over here you have 5,909.82. So should be told really which one is the better option.
Simple interest.
Yeah. It should be 100% correct there. Right? Yeah, that's the answer. Are the rest of you all back? Let me know, guys. I have to clear up this little mistake.
Yeah, I just reached back.
All right, so Amy, that's you talking, right?
Yeah.
So Amy, I did do this question. I made a little mistake. I said n was 9. Can you recognize what I was wrong? Why can't we use n as 9? Why can't we do that? Why would that be rubbish? Tell me. If you know, let me know. Or would you have used 9?
I'm not sure, but I remember when I was doing it, I used the what did you I used the
Use the EP and GP formula.
yeah.
Yeah. But
I didn't really think about that.
well, the reason is, let me share a previous example we looked at. In this example, notice that in January, let's just say in January, right? In January, you put in X amount of money. When do you get the return on investment?
End of the year.
At the end of the year, right?
Mm-hmm.
So keep that in mind. You always get the investment at the end of the year, 1 year from when you put it in. So in this question, they are saying, what is the sum of money in the university fund at the beginning of the 9th year? So at the beginning of the 9th year, it's going to have the same amount as it had in the 8th year because it just get the investment from the 8th year. You understand?
Yeah, I understand.
Yeah, so that was a trick in this question. I need to go over. Right. So let me start calculus. Okay.